the convener and the organizing committee for arranging this beautiful event. I hope that yesterday's session was fruitful, and now I welcome you all again to enhance your knowledge for the following day. Let's start the session with a quote. The beautiful thing about learning is that no one can take it away from you. Now, I'm honored to welcome Dr. Sidambaram Sabarathinam Sir, Research Scientist at the Water Research Center, Kuwait Institute for Scientific Research, Kuwait, a gold medalist in UG and PG degrees. Initially, worked as a junior research fellow in Drinking Water Mission project on fluoride in groundwater. Later, joined as a lecturer in Department of Earth Sciences in 1998 at Annamalai University, served as a professor and head from 2015 to 2017. In an academic career with 19 years of teaching and research, he has supervised 18 MPhils and 18 PhDs. He published more than 250 articles in peer-reviewed journals and edited 10 books in the field of hydrogeochemistry, and is an associate editor in the Kuwait Journal of Science and Coal Geology. He was awarded the Best Paper Award by Applied Water Sciences Journal for 2013 and also awarded for the Best Contribution in Hydrogeology and Environmental Geochemistry in 2016 by Indian Society of Applied Geochemists. Now, I request Dr. Sidambaram Sabarathinam Sir to deliver the keynote address through online.
Good morning to you all, and thank you for your nice words and a good introduction. It's really a pleasure for me to join you on this occasion, and it's a pleasure that I joined this conference virtually. Actually, I wanted to come in person, but because of some schedules at the last moment, I couldn't make it up. So I'm happy that I am joining you virtually, and thanks to Dr. Selvam and the organizers for inviting me and to give a lecture on the sustainable developmental goals with regard to water. So when Dr. Selvam approached me and I said it would be better if it is on sustainable developmental goals aiming on water. So he was very happy about it, and then I thought it would be more appropriate to see. Actually, I couldn't share my screen. Can you? I think there should be a permission for you to share from your side.
Sir, it is open.
I couldn't share.
You can share, sir.
Okay. No, it says you must grant permission in order to share your screen. One second. Just a minute. I think there is an issue on this.
Sir, kindly check now, sir.
I think I have given the permission. I don't know. It's not sharing.
Sir, now I have turned on the sharing of the contributor's screen. So I think now it will be available for you.
Yes. Can you see my screen?
Yes, sir. Now it's coming.
Okay. So I would like to share some ideas on the scenarios of sustainable developmental goals with regard to water. Actually speaking, like we had done enough amount of research, enough amount of advancements in science and technology. But the basic question being answered is water available for mankind? And was the basic need of mankind being served even after the development of all these technological know-hows and identification of recharge zones, identification of pollution zones? We have done a lot in many fields of research. But at last, the question remains the same, like where are we in serving the man's basic need of getting a good quality water for drinking purpose first, and then goes to the next needs. So, sustainable developmental goal has a target on which every man should have an access to clean water. So that being the case, I just wanted to bring you the scenario and tell you what are all the targets, where we are, and how countries are being approached, etc. So in that case, in that scenario, I'm just trying to bring you out the targets, indicators, sectorial linkages, and road ahead. So my talk will be on just giving an overview on sustainable developmental goal, and that too especially on SDG 6, because out of 17 SDGs, the 6th SDG stands for water, and status of each targets and the probable solutions, problems and the probable solutions will be highlighted here. Earlier, it was in 2000, we had Millennium Developmental Goals. So there were 8 Millennium Developmental Goals, and subsequently on discussions with the Rio Summit, what happened was there was a target for another 15 years or so. So from 2015 to 2030, there was a target being fixed on Rio Summit. And then they started it as a sustainable developmental goal. So this Millennium Developmental Goal converted into sustainable developmental goals. And then out of this, earlier there were lesser number of countries, it was 193, and slowly more countries joined in this group. And the target for this, achieving the sustainable developmental goal, is 2030. So on this target scenario, we had different goals, like for example, it may be life, maybe with respect to water, it may be with respect to poverty, hunger, so better living, life on earth, life on water. So it had different goals. So out of which the
Sir,
yes,
sir, have you shared your screen, sir, presentation?
yes, I have shared. It's
But
moving.
we couldn't see, only your face.
That's what I was telling you, but you said it was seen.
Only your Google Meet screen is coming. The presentation is not visible for us.
1 second. No, it says it is being shared.
No, sir, only your video is there and other things are not visible.
Is it visible now?
No, sir. Sir, please go to your presentation, sir. It is on the video only. Once you have to go to the presentation.
Yes, I am on the presentation only.
Sir, 1 minute.
Sir, actually your Google Meet screen is visible now, sir.
Yeah. I think in Mac it is asking for a permission.
Sir, actually, please kindly stop this presentation and share it 1 second. I think we will get it. So.
I'll rejoin or I'll stop the presentation.
You can stop the presentation and you can share it again, sir. Sir, actually, he's given permission to open this.
No, the issue is, I think there is a problem with Mac. It is asking permission to share, I think.
சார் இல்லைன்னா உங்க பிபிடி வேணா எங்களுக்கு அனுப்பி விடுங்க சார், நாங்க வேணா எங்க ஷேர் பண்ணிக்கிறோம். இஸ் இட் ஓகே?
Okay, just give me 5 minutes. I'll shift to another system and
ஓகே சார்,
just give me 2 minutes. I'll shift to
நோ
another
ப்ராப்ளம்
system.
சார், யூ கேன் டேக் யுவர் டைம்.
அந்த லிங்க்ல கூகுள் லிங்க்ல sir is okay now.
Can you see the screen now?
Yes sir, yes sir, please proceed.
Okay.
So just you can hide the PPT.
1 second.
Sir, put in slides. Oh, okay, okay. So remove the height.
I think there is a problem with the connectivity here. I think I had to switch to another system.
Okay, sir,
So
now,
sorry for this, and so I'll just run through a few slides. So this is on sustainable developmental goals, as I was mentioning about this. My talk will be something on, I'll just give you an introduction on sustainable developmental goals and on targets, then status of each targets, then highlight something on the problems and probable solutions. As I was talking to you, it was the Millennium Developmental Goal, which was from 2000 to 2015. And 2012, we had Rio Summit. And then in 2012, another 15 years of a plan was derived. And that was named as a Sustainable Developmental Goal after the Millennium Developmental Goals. And nearly about 193 countries joined this group. And then we have 17 Sustainable Developmental Goals of this to be achieved on 2030. So that being the case, out of the 17 sustainable developmental goals, water is one of the main criteria on which the other sustainable, similar to other sustainable developmental goals. For example, you have 17, out of which sixth is water. So water as such has its own importance, as you know that it's a very scarce commodity and it varies, it's getting polluted and energy is being generated. So it has a multi-parameter and societal oriented objective. So in that case, you know that there is a problem in two different aspects. One in on the quality of water, the other on quantity of water. So you know that if I have kept two diagrams here, if you can see this, yeah. So if you can see this part, it's on quantity of water, and this part is on the quality of water. So the quantity of water getting recharged is lesser in many regions. See, if you can see in Arabian region, the quantity is lesser to be recharged, means renewable water resource is very less on the red color part of it. And then salinity, as you know that with respect to years, this is a diagram with respect to salinity. So with respect to years, the salinity is getting increased in many of the aquifers. So quality is also getting deteriorated and the quantity of water is also getting deteriorated. So that being the background, this structure on the right hand side or the left hand side of yours, which can indicate you that this is a Stockholm cake structure, wherein on that conference, Stockholm conference, it was a cake-like structure was presented. And then you know that there are 17 sustainable developmental goals displayed here. And this is first based on the life. So that is the biosphere. Then comes the societal influence. Then comes the economy. So on all these structures, the basic life existence on Earth is made by 4 different parameters, out of which water is one among them. You know that water and life on land, life of marine, and then climate change. So these are the basic criteria which considers as the biosphere. So for any life to exist on Earth or any life to proceed with its developmental activities, for example, agriculture or industries or drinking or any other activities or even economy, water plays a very important role. So that is that is how the SDG 6 is centered, and it is related to all other sustainable developmental goals. May it be any kind of a high level development which happens in the society is based upon the basic commodity called as water. So in sustainable developmental goal 6, you have other separate targets in each sustainable developmental goal. As you know, if you have 17 goals, each goal will have targets. So out of which sustainable developmental goal 6 has its own target. So means it has 6 targets apart from A and B. So now if you can look at the basic first target, for example, equitable access to safe, affordable drinking water, and then sanitation. So if you can see in most of the programs in India, you Swachh Bharat missions, or in many of the accessible water resources to accessible drinking water to the people, these were the first 2 targets was kept as the prime achievement goal in most of the Indian government activities. That Swachh Bharat mission is for equitable sanitation and hygiene. So that is to achieve this particular target. And then there is 6.3 means reducing pollution, and then water use efficiency. 6.4 will be water use efficiency, increasing water use efficiency. 6.5 is integrated water resource management system, and 6.6 is to restore the water related ecosystems. And to achieve all these six, you need to have international collaborations or development of manpower or capacity building. So that can be also taken in an international level, or you may have an NGO, or you may have a local governing water governing bodies. So that can also influence the water resources management system. So for that, we have two goals below. That is 6.A and 6.B. So A will be international capacity building, and B will be the local community or the local participation of the people. So for any achievement or anything with related to the society to be achieved in a long term, there should be a societal cooperation between people, or the people should take it as their own responsibility to enhance the security of that commodity. So if that is the case, so then the target will be easily achieved. So that is why you have a target on 6.B. That is the local body or the governing body should have its own responsibility. So these are the basic targets among which it will be achieved. So now, for example, to monitor all these targets means we call it as custodians to take care of the data or to take care of what is happening in each country, etc. So each target has their own custodian. For example, safe drinking water is maintained, the data for the safe drinking water and the sanitation is maintained by WHO. And for example, if it is reuse, or if it is with respect to the water use efficiency or maintaining pollution, then it comes to the other custodians. So for attaining the sustainable developmental goal, it doesn't mean that one particular organization in the world maintains the data set of each commodity. They have separate custodians which maintain the data set of each commodities, may it be for quality of water, may it be for example, 6.5 is integrated water resource management system, that is transboundary aquifers, etc. So that will be on ENEP. So you have different custodians to manage different targets or to achieve different targets of sustainable developmental goal. May it be of a single goal also. So this is just to indicate. And then, as per sustainable developmental goals, we have groupings of countries. So you can see here the colors indicate the groups of the countries with regard to sustainable developmental goals. You can see most of the northern part of the continental region, or adjoining the polar region, they are all falling in one group. So if at all you talk something about the sustainable developmental goal regions, so this is suppose for example, you consider it as Europe and North America region as one region. And similarly, each region has its own names. You have Oceania region, means all the island countries will be in Oceania region. And these are the groups which we generally talk about when we talk with respect to the sustainable development goals. So coming to water. So this is with respect to global status of water. And I have introduced you to what are all the sustainable developmental goals. There are 6 sustainable developmental goals for sustainable development 6. And there are 6 targets, and you have A and B. So out of this, where we are. So what we have done so far. So you can see that for each target, based upon the data, we can see that we have achieved 73% of it. The highest achieved percentage, this is on 2022. But even today, the data is being updated. Now the data is around 93. So there are certain sectors where you can see there is a little amount of development which has taken place. For example, water stress, it is very less development has taken place. For example, ecosystems, for example, dams, other water related tanks. And these are water related ecosystems wherein developmental activities have not yet taken place. So you can see that there are places where we concentrate more and there are places where we concentrate less. It has to be hand in hand kind of a structure. Why? Because in the water related ecosystem, for example, with regard to recharge. So when recharge increases, obviously you will get a higher amount of water which is being the quantity of water will be increased. So for a water-related ecosystem to be improvised, then definitely you should have a concentration on the target of 6.6 or 6.5. The target should be concentrated there to enhance the water resources of a region. So everything has to go hand in hand. So now we are trying to, the UN is trying to improve the water stress, improve the ecosystem, and then the transboundary management, which is now taking place in a higher scale now. So this is the current status of the sustainable developmental goals of water. For example, if it is on 6.1. So if you can see here, I have kept two diagrams. One is with respect to two different time periods. This is on, you can see that this is with respect to nation, total with respect to nation, and this is the available with respect to water resources, means safely managed water resources, and this is with respect to drinking water resources with respect to different nations. So when you consider with respect to countries, if you can see that 6.1 goal is almost, we have near 90 to 100%. In India, we have achieved nearly about 90 to 100% that each man gets his drinking water. So almost we are there near the target, and there are countries where you don't have enough access of water, especially in the African region. I'll try to highlight more on the sub-African region later. But just to tell you about the status where we are with respect to each countries. So then this is 6.2. This is on sanitation and hygiene. For example, you know that what sanitation and hygiene means. That is the basic motto of the Swachh Bharat movement. So where current status, we are moving towards the sanitation and hygiene goal, and we are almost 75 to 90% we have achieved on that. We have still to go, and we will be achieving that somewhere in 25 to 27. 2025 to 2027 is a target for India, which they have kept on achieving this goal from 90 to 100%. So there are countries, again, if you can see more on the African region, where they have not yet reached the sustainable developmental goal with regard to 6.2 as a target. And as I told you, in consideration with the sub-African region, there is something which we should concentrate now on in a minor scale. You can see a graph which I have kept here. These red dots, these are all the countries in Africa. And there are urban regions which are concentrated more, which require sanitation facilities, and these are rural regions. So now if you can see this urban, most of the states or the countries in Africa, and these red dots indicate rural regions, and these blue dots indicates the urban region. So now you can see there are developmental activities yet to be concentrated on the rural regions, and the distance between the red dot and the blue dot indicates that almost they are closely achieved. And see, you can see there is a big gap here. In Ethiopia, for example, in rural regions, the development is lesser, and the urban regions, the development is more. But somewhere in Mauritius, if you can see, the gap is being minimized. So this is where we will have to concentrate on, where both urban and rural regions has to be developed parallelly than concentrating on urban regions alone. So such kind of water accessibility divide has to be planned in a country to enhance the water availability for sanitation, both in urban and the rural regions. So now, improving the water quality, we are talking more about the chemistry of water. We are talking more about the pollution. We are talking more about the seawater intrusion and the climate change related to seawater intrusion studies. So anything with related to chemistry, anything with related to the contamination or quality. So therein we are, for example, we are studying the status of water, but what we have done for the improvement on the quality of water is still a question now. We have a lot of studies. For example, in India, if you can see that n number of publications are coming out of India. So competing with two different countries, if you can see on China and India, you have a lot of publications coming out on water and water chemistry. But the steps taken to conserve the water resources, means how do you prevent or how do you take it back to the ecosystem? Means how do you prevent it, or how do you make it back to the original, or the revert it the polluted water to the fresh waters? So that still remains a question where you will have to accelerate on, and we'll have to increase this kind of activities to improve the polluted water resources and to prevent the pollution on the water resources. So that part we are still on yet to take that momentum on. So this is where we stand with respect to 6.3. So now there are two different scenarios where we talk about. One is called as the linear economy, and the other one is called as the circular water economy. So wherein suppose you, if we are concentrating on 6.3, nowadays countries move towards the circular water economy, and earlier it was on linear water economy. The linear water economy is something like you take, make, and waste. So these are the three basic stages where the linear economy stands on. Like you're taking the water, you're using the water, and you're disposing it. Means it's wasting. So you are not considering the waste. We were on that scenario earlier stages, but now out of the development of lot of technologies of treating the water, even now on the desalination part, we try to get the minerals out of the sludge. So that means we are concentrating on zero liquid discharge. On zero liquid discharge, we try to even extract the solid forms, of which the treated water and will be again supplied to the system, and the sludge again we try to concentrate the salts and we take it out. So we try to reduce the waste and reuse whatever which is available to us. For example, even in the domestic wastewater systems, we try to treat the wastewater, either recharge it to the aquifer or use it at least for landscaping or other domestic purpose, other than if there are issues with respect to drinking water, then we can try to use it for landscaping or other car washing or any other kind of an issue. So circular water economy helps us to keep the water resources or prevent the further usage of the less available freshwater resources. So we don't contaminate. So there's another issue that you are again, linear economy, you are producing a chemical or a polluted water which again contaminates the fresh water, which reduces the available freshwater quantity too. So that being the case, when we move into circular water economy, we are trying to restore the water and prevent it from the contamination of the available freshwater resources. So the basic circular water economy principle is reduce the waste and reuse whatever available and restore what best can be done for a different purpose. So there is another criteria coming up, we call it as fit for purpose. So fit for purpose is something like, for example, you have a saline water or you have a brackish water. We have to consider or think what this quality water can be used for. Even if you don't treat, or if you don't take further steps for treatment of the that quality water, as such that quality of water can be used for what? So that kind of utility, we call it as fit for purpose utility. So that also comes in a part of the circular water economy. So that being the case for 6.3, it is aligned with 6.4, how best you can use the available water resources. But for example, basic, suppose we know paddy is a water loving crop or banana is a water loving crop. So there are crops which loves more amount of water. So it is not necessary that water is to be supplied for a particular crop throughout its stages of development. For example, from the sapling stage to the developmental or the final stage where it yields the banana or the paddy. So till the last stage, it doesn't mean that you will have to irrigate the crop with the flooded with water. It's not required. So at each and every stage has a specific requirement. So it's better to govern or use water effectively according to the need of the plant or any of the use utility. For example, it's not for the agriculture alone, it can be for any other purpose also. Use water according to the need. It's not necessary that you should use water because you have it. So now we are into smart water systems, wherein you have IoT systems which can enable the equal or the needed amount of water. Means what quality of water you need and how much amount of water is required and what timing it is required. The IoT systems on the device and the water is being led to the utility, may it be crop, agriculture, or any other kind of an utility, and after a particular time it automatically cuts off. So that kind of smart agriculture systems, and based on IoT systems, we have developed. There are a lot of systems, smart agricultural systems now being developed in India. You have Bangalore-based companies. You have NRS. NRS. I don't get the abbreviation. There are the systems which can incorporate with the major governmental bodies. Even NGRI has a system which has been in collaboration with the other agricultural commodity, for example, with CSIR and with other IGCAR, and they have an agricultural system which can integrate all the available water resources based on the smart water system to apply for the agriculture utility. So they are developing scenarios in which how best water can be used based on this efficient water use management system. So there we are, but still we are in 50 to 75. It was in, I think I have taken this in June 2024. So might be we have a development on subsequent years when there is an annual report on sustainable developmental goal. Then we will know further where we are in the next year. So this is how on 6.4 we are targeted by. And on total, how much units are being converted means now we are trying to move into sustainable developmental goal based on the water use efficiency. You can see more number of units we have targeted. On the red ones indicates that smart, we are more into the effective use of water management systems. And here, yes, since I am from, I am representing the MENA region, Middle East and North Africa region. So I just wanted to have 1 or 2 slides on that. So I have just kept it here. The Middle East and North Africa region represents this part of the globe where we call it as MENA region. So in MENA region, you know that the amount of water, obviously, yes, we have a lesser amount of available water, means as a natural resource. But still, if you can see the utility of water, per capita utility of water, Kuwait is one among the highest per capita utility of water. Means it's around 400 LPCD we use daily for normal resources. So that indicates that the desalinated water is being consumed, or it's being used to the maximum. So now we are trying to go back and see what best can be done to manage this effectively. So though most of the countries on the Middle East, North Africa region are concentrating on desalination plants to increase their water resources, freshwater resources, we are now trying to move on to the zero liquid discharges so that it doesn't affect the environment, and we try to extract the minerals too. And we also depend upon the power generation for the treating the waste. And then we are blessed with something on the solar energy. So we are trying to integrate all this and reduce the environmental perspectives and achieve the 6.4 target. So that being the case, there was one study, if you can see this diagram on the right, wherein you can see that the agricultural percentage of the agricultural area and with respect to climate. So the amount of water used, for example, how much amount of water, percentage of land under cultivation, and the precipitation with respect to evaporation, or with how the water is being used. There are countries, for example, if you can see that in humid regions, obviously, yes, you will have enough amount of water. But the water level has gone down in most of the hyper-arid and arid regions when you use more amount of water for agriculture. So this is a recent study which was published in Nature, wherein it indicates that agriculture is one of the basic, a basic consumer of the freshwater resource. So now a strategic plan has to be managed in such a way that where this arid to hyper arid, now it has started in semi-arid countries too, like targeting the deeper aquifers. So we should have an alternate plan in such a way that for agriculture, we should sustain with more amount of freshwater resources, or on the surface freshwater resources, or with treated wastewater resources. So that was the sustainable developmental plan, which has to be targeted on 6.4. So we have to consider the climate, we have to consider the area which is considered for the agriculture. And for example, if it is on hyper arid region, we'll have to go for an alternate cropping system which consumes lesser amount of water. So the cropping system, the mentality now, you know that the climate is being shifting its own pattern. For example, if we had two sets of monsoons, southeast monsoon and northeast monsoon, so of which you have the southeast, we call it as jas monsoon, June, July, August, September monsoon. So this June, July, August, September monsoon is now shifting its time period. For example, if it is, for example, it is to start on June, but sometimes it starts on July, and it extends even up to October. So that on the pattern of the monsoon itself. But still, we have the basic traditional mindset that we start our agricultural activities on June, expecting that rain to start on June. So we will have to be in coordination with the society and the farmers and indicate them we are on the verge of climate change. So we'll have to shift the cropping pattern. And similarly, for example, if you have to get 900 mm of rainfall per year, now what happens is you have intense rainfall, means very short spell of intense rainfall. The same amount we are getting throughout the year, but the duration of rainfall is getting reduced. So that means higher amount of rainfall in a short period. So that results in flooding and that results in crop damage. So we will have to study this pattern and educate the farmers to come up with a different alternate strategy for cropping. May it be with respect to type of crop, may it be with respect to water loving crop, may it be with respect to the type of crop which can sustain such kind of environment climate change issues. So that will help us to achieve the sustainable developmental goal 6. So now when we come to 6.5, so this is on cooperation. So how best water can be integrated between different nations, integrated between different countries or geopolitical boundaries. For example, it may be between one taluk to the other taluk, one district to the other district, or one state to the other state, one country to the other country. Everywhere you have an issue with respect to water boundaries. So beyond geopolitical boundaries, this is a natural resource. So natural resource, if it is not maintained in any of the geopolitical boundary, it affects everybody. May it be the upstream region, may it be the downstream region. You will have an enough impact on, for example, if you have a small climate change somewhere in some part of the world, it affects the water resource. For example, you know that the trade winds, or we call it as easterly jet, which starts from China. For example, for our monsoon, it starts from China, northeast, then it comes through the Tibet, it comes down to India, then it goes back to the southern part of Arabia, and then dry air goes to the Saharan region and comes back again to the southern part of Arabia, and then comes back to India during northeast monsoon and goes back to China. So this is one cycle where the water, the moisture is being transported. Now, if there is a small, big volcanic event taking place in one part of China, or there is a deforestation taking place in one part along the travel route, automatically this microclimatic change will affect the entire cycle. So it doesn't mean that an impact taking place in one part of the world, so it means that one part, if there is a change taking place in one part of the world, it affects the entire global scenario itself. So considering that, we should always think that this water is a common commodity and it should be managed by all, beyond all political boundaries. So that being the case, so where we are with respect to integrated water resource management system is we don't have enough amount of data, and data may not be shared by different countries. That is the problem. So they think water resource is only their property. So what happens is they think it is a confidential data and they are not sharing the data. So that being the scenario, it will be difficult to manage the water resources. So if you want to have a treaty, if you want to have a cooperation between two different political boundaries, then obviously you should have enough amount of data to be shared between the countries. So wherein this is the transboundary governance with respect to surface water, there are different countries. You have surface water governance. You have about 153 countries in the world, which has about 286 river basins, and you have 592 major aquifers. There are other minor aquifers also. These are all the major aquifers in the world, wherein you have cross transboundary aquifers. some places you can see that there are light colors and the dark colors. The dark colors indicate, there are two layered aquifers sometimes. The upper layer also will have will cross the border, and lower layer also will cross the border of a country. So upper and lower layers will be there. So these are the scenarios of different transboundary aquifers. With respect to MENA region, obviously, if you can see that there are nearly about 25 transboundary aquifers, of which Ramco aquifer is a bigger aquifer, wherein we have transboundary issues, and we have treaties to manage these aquifer, either in the waterhead regions or even in the distributed regions. We have so far we didn't have issues on this, and there is a amicable solutions going on when sharing the water resources of different countries on the GCC region. And this is to protect the water related ecosystem, wherein you can see that suppose, for example, if it is to be dams or reservoirs or any kind of water tanks, any kind of recharge structures or surface water resources are to be preserved. So steps are to be taken which are not concentrated nowadays, because that affects the ecosystem for recharge. So we are at the beginning stage. We are to enhance this particular water resource management system. And 6.6, obviously, yes, the biodiversity of the region. We will have to concentrate more on the biodiversity of the regions. So that also we are still lacking on. We have to accelerate this particular point. And yes, international cooperation with respect to water. So may it be any kind of an international agency. For example, it may be WHO or UNICEF or World Bank or any other kind of an international organization which gives training for water, which develops the manpower for water. So based upon that cooperation, we have a lot of areas which are being converted recently. This is 2020 data. If you can see that there are a lot of developments taking place in India with international cooperation, which you can see that blue area which is being developed. And now if you can see local participation. So the problem where we have is the local participation. Though we don't have enough amount of data, unless and until the change comes from the community, unless until the people take the responsibility to maintain the water resource, it should start from panchayat level, village level, district level. Unless and until people try to manage the water resources on the basic community, you can implement a lot of systems, but implementation stage means to execute that, people cooperation should be there. It is their water resources. It starts from the home. You should conserve water for the home, then the village, then the panchayat. So it goes on, like from the bottom to top approach will be a success of the scheme rather than the top to bottom approach. For example, to an overview, I'm just giving you the commodity. So there is something called as virtual water transfer. For example, you produce a textile, for example, t-shirt. One t-shirt consumes about 2,700 liters of water. And similarly, one pair of shoes, to prepare one pair of shoes, 16,600 liters of water is used. For example, 100 grams of chocolate, 100 grams of this chocolate, you need 2,400 liters, right from the crop germination stage to the final product stage. So these are all some of the ideas which I wanted to put in front of you, just to say how much amount of water is being used to produce this commodity. So that is called as the water footprint. This we call it as a water footprint. And suppose we say we are proud to export a higher amount of sugarcane. We are proud to export higher amount of textile. Means indirectly we are transporting higher amount of used water resources to another country. There are countries which don't produce this, even they do have enough amount of water resources. Considering that, they will conserve the water resources for future, and they will use it when it is required. So now we will have to act judiciously, and industrial development should be in a judicial manner, in such a way that we should produce products which consume lesser amount of water, or you should have an alternate water management system to supply for these countries, for these industries. So this virtual water transfer should also be taken into consider, and the water footprint of a commodity should also be taken into consider when you manage the water resources. As I was talking to you about the participatory water resource system, it's always from the bottom to top approach. You should directly, it cannot be from the ministry directly to the people. You should have a maintaining group in between, for example, a governance, and then that you should have people on the ground who manage the water resources. So unless and until you have a micromanagement system for the entire water resources, you will not be able to manage the water resources. So that's why we need a local, the 6.B, the last part which I showed you as a target, will play a key role in attaining 6.6 sustainable developmental goal 6. So 6.B is a very important component on sustainable developmental goal. So one small example I would like to give on China, wherein we had called as a river chef system. I'll just run through this particular example, wherein it was a very success model. There was one particular village which had polluted water resources, and many people started complaining about it. And government also gave some funds, and they were not able to solve the issue. Then what happened was a group was formed within the community itself, and then there were chiefs within that, and each and every family had its own responsibility to prevent the pollution entering the water resources. And then slowly they started treating it, and then they reclaimed the entire water resources of the region. So this system was very successful when people started participating in. So unless and until you have a participatory approach, means people participatory approach, you will not be able to succeed with any implementation plan. So that is the micromanagement system which is required. And now China has started this kind of river chef system throughout the country now, so to manage its water resources. So that kind of management system has to be there on different components. So wherein here we have, I'll just sum up this diagram. We have developed a lot with respect to, we have policies. It doesn't mean that we don't have a policy. We have enough amount of policies, and we have enough amount of, on the left hand side you can see that this is all science and development, and this is all policy and governance. We have enough policies. We are at the helm of affairs of the technology with related to any of its kind, may it be IT sector, may it be water related sector or treatment sector. We are at the helm of affairs. We are at the top of any technology. But still, coming to the basic man's need of availability of water and water reuse and management system, though we have enough policy, though we have enough technology, we are still not able to achieve. It's because of integration. This technology is not integrated with the policy, and if it is integrated with the policy, it's not managed with the people participation. So we should integrate these two components to get or succeed in any sustainable developmental goal of that matter. It may be water, or may it be life on earth, or any other sustainable goal of that matter. There has to be a science and technology integration with the governance, and with people participation, you can achieve the sustainable developmental goals. And I don't want to explain much of this diagram. Each goal is not independent. I just wanted to say that point. You will have integration of each goal. Suppose you develop sustainable water goal 6, for example, for agriculture, enough amount of water is being supplied. Then that addresses another goal of life hunger. Means you will have produce, this will be associated with production of crop, and that will help to solve the poverty and hunger. So that means each sustainable developmental goal has its own targets, and each target are interlinked. So if you develop one target, the other target of the other sustainable developmental goal will be achieved so far. So that being the case, you can see how water is being related to other sustainable developmental goals. All these light blue dots indicates water. It's all related to other sustainable developmental goals too. So this is basically the water component, and how it addresses the other sustainable developmental goals is given here. So water is a basic component for any development of sustainable developmental goals of that matter. And where we have reached with respect to each sustainable developmental goal and water. So just to show you that how water plays a very important role with respect to the sustainable developmental goal, and where we have developed, how much percentage are developed with respect to each goal. So with respect to water in total, you say 6 sustainable developmental goals in total, how many percentage we have developed is still, we are somewhere around 60 to 70%, or even 50% only in total with respect to all countries put together globally. So we have only 5 years left, but still things have to be accelerated and to achieve this entire target. So as I told you, each and every target is not independent. It is all interrelated. So you have cross-sectoral partnership should be there, extra-sectoral partnership should be there, inter-sector partnership should be there, and regional cooperation should be there. Means international cooperation, regional cooperation, and then each, for example, if it is water related partnership alone should not be there. You should have IT people, you should have agriculture people, you should have other society related people to be a part of the water management system, so that it's not an independent, it should be a dependent management system. So that is why you should have sectoral partnership to achieve the sustainable developmental goals. If you are not achieving this goal, there will be displacement or migration of people from one place to the other. Means from where you don't have water resources, for suppose you don't have water resources in rural, then people move towards the urban. If you don't have places where in the coastal regions, when the population density starts increasing, you will have more dependency of water. So there will be displacement of population from one place to the other. That is one consequence. For this, what we can do is we will have to educate the people right from the school age and tell them the importance of water, what water can do, and how we have to manage the system. Earlier days, we have something on moral science, something we had on social responsibility of people, civics, etc. Now we should add this water inculcation, water management system as an inculcation technique to the future generation. And again, we should integrate all the science and technology, like kind of IT database systems and available research which has taken place, case studies which have addressed certain issues in other parts of the world to solve our problem. Everything should be brought in one platform to integrate and develop the sustainable water resource management system in total. So it is not the government alone to responsibility to achieve the water resources. It can give you the technique, it can give you the capital, it can give you the manpower, but still management lies in each citizen. So citizenship science plays a very important role, or the participatory approach plays a very important role in the governance of any water management system as such. And these are all different governance with respect to water management system. It may be tariff or without tariff. It all depends upon finance, obviously. So budget as such should be allocated, and I wish to conclude that it is a responsibility of all citizens to manage the water resources. And again, if you can see this one diagram, which one photo which was impressed when I had the visit there in China, wherein there was an antique piece in a museum. They have kept this structure. Each tap was locked. Means those days, each community or each family had a tap in which they were responsible for, they can collect water from that tap. So they had a lock in each tap. Each family had this is a public water system. So each family had a lock in the tap, indicating the governance or the importance of water for their family, because they are metered. So unless and until you know the value of that commodity, you will not preserve it. So you cannot live without this commodity. You cannot think a life without this commodity. So we will have to take it in multi-dimension to conserve this commodity for future. And sustainable developmental goal 6 is a basic need for mankind for any development of sustainable developmental goal. So thank you very much for the opportunity given. Thank you, and thank you. Wish the best for the entire conference. Thank you very much.
Thank you, sir, for your valuable insights and thoughts about sustainable development goals in water. Now, I cordially invite Dr. N. Rajamanikam, sir, to honor Dr. K. Srila, sir, with shawl, memento, and certificate. Thank you, sir. It's time to welcome Dr. K. Srila Sir, Scientist D, Hydrology Group, National Center for Earth Science Studies, NSIS, Kerala, India. He completed his doctorate on Water Resources and Environmental Engineering, Department of Civil Engineering, IISc at 2014. He was a research engineer at INRA Avdon, France at 2016. He was awarded with a gold medal and first rank in Master of Engineering from Center of Water Resources College of Engineering, Guindy, Anna University, Chennai at 2009. He is a recipient of Best Paper Award in the area of Environmental Science at 2017. Now, I kindly invite Dr. K. Srila sir to deliver a keynote address.
Yeah, good morning, everyone. And I thank Professor Selvam and other organizers for giving me an opportunity to deliver a keynote address in this international seminar on air, water, and sediment regime and its impact on climate change, a sustainable development goal. So I'm basically a hydrologist. I work at the National Center for Earth Science Studies. We are an autonomous institute under the Ministry of Earth Science, Government of India. So the institute is located in Thiruvananthapuram in Kerala. So just the previous keynote, Professor Chidambaram spoke about the sustainable development goals, water quality, sanitation, and many other things. I speak still on water, but on a different perspective, mostly on the research that has been going on with respect to climate change and its effect on water sources, how the hydrological cycle is intensifying or accelerating under the global climate change, and what changes are there between the surface and subsurface water, that is groundwater and surface water, what changes are happening during the interaction between these water components. Okay. So when I put the title as acceleration, or it is intensification of hydrological cycle, you know the hydrological cycle, it starts with rainfall, it falls on the ground, makes runoff, some part of it goes recharge, this runoff will reach ocean, then there's an evapotranspiration, the water goes back to atmosphere. So this cycle takes place continuously and there is no loss of water, but water is stored in different packages in different places as different components. So the idea here is like how fast is this hydrological cycle taking place in the context of global climate change. For example, what we are talking about is a residence time of water in each of these compartments. We are talking about rainfall or atmospheric water. We are talking about the water that is available on the land surface, and then what is available on the groundwater's recharge, and then going back to the ocean and evapotranspiration. So what is the residence time? Like how in what time period the water stays in a particular stage or particular system. So that intensification or that change or that acceleration of the hydrological cycle is what we are talking about. And you can see this, the meaning of this acceleration in the recent time is that you see high intensity rainfall in a very short period of time. Like last year, there was a flood in Thoothukudi, and last week there is a flood in Spain where they say that one years of rainfall happened in 8 hours. Okay, so that is kind of the acceleration we are talking about. Too much of water coming into the system at a short period of time. All these are going as runoff to the oceans very fast, and because of global temperature rise, we are having too much evaporation. Evapotranspiration has increased. This is water is going back to atmosphere. So this is the kind of cycle and speed up of the cycle that we are discussing here. So this is the study on acceleration of hydrological cycle has started like probably 6-7 years back. People started talking about how this cycle is changing. For example, this is a study from US. You can see what kind of changes are taking place in the with different variables. For example, you see the maximum temperature on the top figure. The red portions are the accelerated change, whereas the green portion or blue portions are less change. So you see towards the right end of the graph, you see that there are mostly red portions for evaporation, the minimum temperature, rainfall, etc. And if you look at the groundwater level and soil moisture, it has reduced. So that means we are having less of a storage component, but more of a loss, that is runoff and evapotranspiration. The scenario is not an isolated one, because you see the global, what we say about global climate change is basically the temperature change we talk about. So the temperature change, like you can classify it as several orders of impact. The rise in atmospheric temperature, that will first leads to, if you look at the hydrological impacts. One is the glacier melting, higher evapotranspiration, just like I told. Shift of the seasons, like Chidambaram sir mentioned about the shift of monsoon season from June, July, August, September towards rain starts from July to October, or shifting of rainfall, peak rainfall from July to September, those kind of things. And low precipitation, high precipitation, both the cases, flash droughts and flash floods. But the impact of these hydrological impacts on environmental impacts, because of the second order impacts, we are having a third order impact, which is like listed below. Rise in seawater level, groundwater depletion, the pollution because of either availability of excess water or non-availability of water, pressure on the land cover to take up all these impacts in the second order impacts. And this leads to the socioeconomic impacts, which just Chidambaram sir talked about, the freshwater crisis, water quality issues, social conflicts, changing water policies, high energy demand to sustain because of higher increase in temperatures. Now, if you look at the Indian context, we are at one side we are seeing increased ocean salinity because of large evapotranspiration that is taking place from the oceanic system. But also we are seeing increase in temperature, that is again evapotranspiration from the land surfaces. So the Indian subcontinent is like very complex. You have a heterogeneous system of agroclimatic zones with different cropping patterns and different climatic zones. You have the Western Ghats, humid Western Ghats, and then you see the other side, they are semi-arid and arid regions. So you see there is a large spatial heterogeneity in the rainfall pattern, and also the evapotranspiration taking place from the land surface. And then there is a large disparity between the recharge that is taking place from the rainfall and the groundwater draft that is we are pumping out for agriculture and several other purposes. So with this large heterogeneity, we need to see what kind of changes is taking place in India in the context of climate change and water resources. So I focus mainly on the southern part of India, that is South Peninsular India, or the southern part of the Western Ghats, mainly on the region to the east of the Western Ghats, that is Kaveri River Basin, and the west of the Western Ghats. Okay. So the important here, the one thing here, the contrast in this eastern and western part of the Western Ghats is like if you see the Kerala side or the western side, you have small rivers, like maybe 100 or 120 kilometer length of the rivers. They are draining very quickly to the ocean. You will receive 3,000 mm of rainfall in the windward side in the Western Ghats, and then the water quickly drains to the ocean. It's a humid region, and you see the leeward side, that is the Tamil Nadu side towards the east. The length of the rivers are very large, like Kaveri is a very large river system with 80,000 kilometer square area, and there are several other long rivers, but then the flow is generally slower. It has more residence times to flow from the hills in the Western Ghats to the oceans. So we analyzed the change in the rainfall in different months, like starting from January until December, like what is the changes that is taking place in the month, just to see what kind of shift is happening in the monsoon system. For example, Chidambaram sir just mentioned about the shift in the southwest monsoon, but like if you look at the last 3-4 years, the monsoon has shown a shift from like a peak from July, August to September, October kind of thing. August and September, we are getting very peak rainfall, but previously it was June, July kind of thing. It starts at the end of May and picks up in July, but then there is a shift in the peak of the rainfall towards August, September. That is why we saw big floods in 2018 and 19 in Kerala. So that signal is also represented here. If you look at figure G and H, you see that on the blue side is the degrees in the amount of rainfall. That is like percentage change in the rainfall to the total annual rainfall. But if you see H, you see that it's a green button which shows an increase in rainfall. That means there is a notable shift in the percentage contribution of rainfall in July and percent change in rainfall in August and September. Okay, so this is the kind of the rainfall shift we are experiencing. But the question is whether we are adapting to the shift. For example, if you look at the Kerala flood in 2018 or 19, the story there was like we couldn't manage the reservoir. I mean, the reservoir management was an issue that in June, July, whatever rain was available, that was already stored in the reservoir. And when there was an excess rainfall in August, we couldn't manage it. So that means we need to redraw the reservoir management rules according to the shift in the rainfall pattern. So one important thing to note here is like we always do this kind of trend study to see what kind of change has taken place. But like, for example, if you take a 100-year trend, like you have data from 1901 onwards until 2024 from IMD gridded data 0.25 degree. If you look at that 124-year data, you are not going to see a big trend. Okay. In the long term, the trend may not be so visible for smaller regions. That is what we are representing here. If you look at this vertical axis from 1901 until 2015, the trend is more or less neutral. You don't get too much of trend. But if you come close to the later half of 2000 and 2015, you are seeing stronger trends. There are some published papers which say there is an accelerated change after 1980s. So if you consider that data from 1918 to 2024 or something, you will see a different kind of trend as compared to a long-term trend. So the thing here is that when you go for such an analysis to see the change, the data period is also very important. Like long-term data may not show a trend, visible trend, but if you look at the short-term data, we see a very visible trend and a very strong trend. Okay, that is more important because we are looking at what kind of changes is taking place in the last decade or 15 years or so. This is for the western part. The same thing is on the eastern part. You can see an accelerated change towards end. That is after 2000 to 2015 or 25, we are seeing an accelerated change, which was not visible in the long time series. So that effect of the rainfall, which we saw in the last two slides, is also visible in the stream flow. Here I have plotted the South Indian rivers. The blue ones are with positive send slope. That is when you do with a Mankandal trend test, you get positive slope and a negative send slope. That means positive means there is an increasing stream flow, and a negative trend means there is a decreasing stream flow. You see there is a large number of rivers which are showing a decreasing stream flow. And also if you look at the other side, this side of the graph, you see that the stream flow pattern, there are increasing trends in the August South pattern in some parts of the Western Ghats, and in other parts there is a decreasing trend. So the stream flow is also shifting concurrently with the shift in the rainfall. That is why we need to take care of the reservoir management and water source management. One example, here what we talked about is rainfall and the stream flow, but there is something like these the flow during the non-monsoon period, that is flow during the period when there is no rainfall. The river still sustains the flow because of the concept of base flow. Okay. The base flow is the water that is coming from the groundwater to the river systems. But if you look, like I analyzed one example for a Vamanavaram river in South Kerala. So if you see this, the graph at the bottom, like after 2000 or from 2000 onwards, you see long period of no flows. That was not a feature before that, before 2000. So there are some low flow or no flow periods, but this frequency has increased considerably. That means we are seeing less contribution of base flow to the river systems in some of the rivers. This is just an example, but maybe you also felt that there are several rivers which has dried up in the summer season. The thing is that we are not receiving base flow into the river because of land use changes or other factors. And another factor is that even though if you look at the annual amount of rainfall, it might still be the same, but the distribution of rainfall has changed. At some point, there is big rainfall and then long period of dry, we say prolonged wet spell or prolonged dry spell. So this also has an impact because the hypothesis that when you have very high rainfall, major percentage of goes as runoff because you don't have much time for recharge to take place. Everything goes as a runoff. And if you have a low or moderate rainfall, the water has sufficient time to recharge. Okay, so these factors play a role in the changes in the stream flow also. This is just an analysis of the entire Kerala. I mean, I selected 6 river basins for stream flow analysis, but the groundwater level and evapotranspiration, you see the red marks are increased evapotranspiration. So you see that entire Kerala is showing increase in evapotranspiration. That means, see, in Kerala, usually 30% is 20 to 30% of the water that is coming as rainfall will go as evapotranspiration. So this has increased over the last 10-15 years. That means we are losing too much of water from the land surface to the atmosphere. So that means we are increasing the atmospheric moisture. And that is why we are getting very high rainfall at several points. For example, 2018, 19, and even recent years, we are getting high rainfall because atmospheric moisture is getting increased because of increased evapotranspiration. This is another study from the Kaveri River Basin, this part. The first one is the evapotranspiration. You can see some part of the northern part of Kaveri Basin, that's basically the Karnataka region. You have increased evapotranspiration, and in some parts of Tamil Nadu also. The same way, we are also seeing the decline in groundwater level accordingly. It can be either draft, but also increased evapotranspiration demand also sucks the water out of the groundwater system. So you see that dotty plots there. The region 1 shows decrease in groundwater level and increase in ET. The region 2 shows increase in groundwater level and increase in ET. Okay, so that both cases are here. So you see decrease in groundwater level and increase in ET. So the water from the groundwater level is being pushed out of the system. But even in the cases of increased groundwater level due to humid regions or higher rainfall, there is again increased ET because of increase in temperature. So there is enough energy available for the water to evaporate and go back to atmosphere. There is an example from the Periyar River Basin on the other side of the graph. You see between 2 years, 2001 and 12, you see the percentage of evapotranspiration. It was 22%, and then 2012 it was 34%. So there has been a 10% increase in the loss of water to atmosphere. Just an overall picture of the southern India or south peninsular India. See what changes has taken place in the groundwater, the corresponding changes in the evapotranspiration and the stream flow. That means all these are connected, whether it is atmospheric water, that is evapotranspiration, or groundwater or stream flow, are all connected. And that is why we look for studying the system as a whole, that is integrated water source management, we say, or we say about subsurface water interactions. Okay, that is where we come to the next part, like why do we need to study this water source system as a whole, that is consider both surface water and groundwater system as a whole. Like, because many of us focus either on groundwater because we say groundwater specialist and surface water specialist kind of thing. But now we need to change that way, and we need to be specialist in both. We have to study the interaction between surface water and groundwater system at the same time, because what changes is taking place in the surface water is affecting the groundwater systems, and what is happening in the groundwater is affecting the surface water system. So there have been several initiatives for integrated hydrological modeling. There are commercial as well as free softwares available for modeling the ground systems as a whole. So this is the basic concept of hydrological modeling. You have this continuity equation, which is mass inflow minus mass outflow is the change in mass storage. That is a simplest form of representation. So what inflow we are talking about is rainfall. So if you go to Himalayas, you can also add a snow there. But here in our part of the country, the inflow is coming as rainfall. What are the outflow? The runoff, it is losing out of the system. If we take a watershed, the rainfall that is coming in is the inflow, and you have runoff, that is stream flow, that is going out of the watershed, that is an outflow, and the evapotranspiration loss, which is going back. So the remaining part of the water we call is change in storage, that is it comprises of soil moisture, or that is soil water or groundwater. So this is how it comes. Precipitation minus evapotranspiration minus discharge will be the change in storage. This is the basics of the continuity equation, and from this we are looking at the perspective model. So how this interaction between surface and subsurface water takes place? See, when you look at a surface water model, what we are looking at is to model the stream flow. We are not worried about any other factors. We just model the stream flow. Given the rainfall, what will be the runoff at different points or outlet or kind of thing. But then there is one component that is the soil water and the recharge that is going to the groundwater system. Okay, so depending on the amount or intensity of the rainfall, this recharge also will change. So if you don't use a hydrological model or a Wadowson model to model this recharge, what usually you do with a groundwater model, for example, flow, is you have some rainfall recharge relationship. So you assume that a percentage of rainfall is going as recharge. For example, 10%. You use Chaturvedi formula or some formulas and say that this is the kind of recharge that is coming from the system. So let us assume 10% of rainfall is going as recharge. But that is not the case always, because the recharge varies based on the intensity of the rainfall. If there is a very high intensity of rainfall that is taking place in a very short period of time, you get more runoff. This 10% may not be true in that case. You may get 95% going as runoff and very less percent, 5% going as recharge. Okay, that is why we need to bring the surface water system into play, model the recharge from the surface water system and feed that to the groundwater system, so that you will have a better modeling there. So this again, I told about the concept of base flow, how base flow is sustaining majority of the Indian rivers, except probably the Ganges and Brahmaputra, where you have snowmelt contribution throughout the year. But in the South Indian rivers, the sustenance of river is basically from the base flow. Okay, that is the contribution of the groundwater to the stream system. Here, there is an example, like this is from a study by Professor Abhijit Mukherjee, IIT Kharagpur. He studied the changes in the base flow in the Ganga river basin. Okay, so he connected the changes in the groundwater level. The red portions in the Ganga basin maps are the decreased groundwater level, and how this decreased groundwater level is contributing to the decrease in base flow, that is runoff to the runoff in the Ganga basin, which is coming as base flow. For example, this is a conceptual diagram he made. Like, because the groundwater is getting deeper and deeper, there was a time when stream groundwater was contributing to the stream. Now the stream is contributing to the groundwater. So the base flow has ceased. The stream flow also has lowered. Okay. This is an example from Ganga basin. This is an example from the Kabini basin, the upper part of our Kaveri region. So you can see a drastic decline in the base flow over the periods from 1970 until 2010. We have measured the base flow, and you see the kind of change that is happening in the base flow. So if there is reduction in base flow, that means there is a reduction in the flow throughout the year. Much of the flow has been taking a quick runoff, or the groundwater has declined. There is no connectivity between the aquifer and the stream systems. Okay. One other thing is, like, there was a lot of issue about this river sand mining in mainly the Kerala rivers. So once you are kind of doing sand mining, you are increasing the depth of the river. That means the groundwater that time will contribute. When you are increasing the depth, the groundwater will create a slope and it will contribute. After some time, there is a decline in groundwater. This river is not able to recharge the ground because of the natural gradient. It is unable to recharge. So there is a decline in groundwater levels in Kerala rivers as well. So some examples of integrated modeling. How does this work? So I worked in the Kabini Observatory during my PhD, and we developed a model that is just like I mentioned, that the recharge factor that is going to the groundwater has to be well modeled. So we used a crop model, or a kind of Wadowson model. So that component that has a root water uptake, because root water uptake plays a major role in determining the evapotranspiration. So there is a root water uptake model coming from the crop model, and the deep percolation that is coming from the crop model is fed to the groundwater model. That is basically a Parker symbol model, one-dimensional model, and the pumping is fed back to the irrigation model. Okay, so the same thing can be represented as a two-dimensional thing. You have, for example, assume a ground flow, say groundwater model, but the surface part can be either a hydrological model or a crop model, which actually feeds potential recharge or deep percolation into the groundwater system. You can also couple these crop models or agrohydrological models to the groundwater system models, because crop models, though the parameters are very high, this actually gives a better representation of the recharge process, because you have this root water uptake, irrigation, all these factors are taken into consideration in a crop model. And then the water that is coming out as deep recharge or deep percolation, that is actually more realistic value as compared to any other surface model or Wadowson model. So this is the coupling between vadose and groundwater model. You know, vadose, for example, hydrous model. Vadose is this unsaturated soil layer. So you can model that as well. Instead of a crop model, you can use a vadose model and couple that with the groundwater model. Again, the concept is same. You are feeding the recharge flux from the vadose model into the groundwater system and then seeing what kind of changes is taking place. So we run a synthetic experiment because our hypothesis is that when there is a high intensity rainfall, the recharge will be relatively lesser as compared to a moderate or a low intensity rainfall. So we also saw a similar kind of, with the same kind of rainfall, we saw two different kind of recharge. For example, you see around 114 mm recharge taking place in the first scenario, and we skewed the rainfall with high intensity rainfall, reducing the number of short rainfall and bringing the high intensity rainfall. So we see almost 50 mm reduction in the recharge that is going place. This is from a coupled model. We have applied this hydrous and Ambas groundwater model as an example in the Palakkad district to see how the model is behaving with respect to the groundwater that is available, and the model performance is actually satisfactory. That means the coupled models of vadose and groundwater has a better efficiency in modeling the groundwater systems. So this is commonly available, SWAT mod flow. Now, like probably last 10 years, many people have started using the coupled SWAT mod flow. So this is actually a very good modeling. We can one is the tool is free. I mean, open source, you can use it free. And other one is like it, even though it is a like a kind of semi-distributed model. I mean, SWAT is a semi-distributed model and mod flow is a fully distributed model. But the advantages of the model are coupled here together. That means you can model both surface and groundwater components at the same time, and you also can see the interactions at different interaction between aquifer and river, or aquifer and streams at different points, like a kind of time series. This is an example from the Netravati river we did some times ago. So on the right hand, you can see that stream lines and the kind of input that is coming. Either the stream is discharging to the aquifer, or aquifer is discharging the stream. So this kind of data we can generate by using a coupled model to see what are the areas in which the stream is contributing and what are the areas in which aquifer is contributing and what kind of changes is taking place with respect to rainfall and changes in land use, etc. Okay. Now I come to the third part. So what we have talking about all these parties, like we are talking about the atmospheric system, we are talking about the vadose, we are talking about the groundwater. If you look at this concept, there is a concept called critical zone, which has been developed probably in the early 2000. Okay. So the idea is that you study everything from the top of the canopy to the bottom of the aquifer, because you are talking about evapotranspiration, you are talking about soil water storage, you are talking about groundwater recharge, and the surface water flow. So all the process is taking place in this layer. Whatever process we are talking about, all are taking in this layer. This is called the so-called skin of the earth, very thin layer at the top of the earth surface. Okay. So the thing is like, why do you want to study this? Because if you look at our like Central Groundwater Board, they measure groundwater level at different points. Central Water Commission measures river stages at different points. And then there are different agencies measuring different things at different places. But if you could measure everything in a single watershed, you measure evapotranspiration, you measure soil moisture, you measure groundwater level, you measure stream flow and canopy, everything in a watershed, then you will be able to understand the system as a whole. Okay. Unless you have all these measurements, you are always missing some observations in when you are trying to model. You take Kaveri river basin, you will have a stream flow, you will have a groundwater level, but where do you go for a soil moisture or evapotranspiration kind of data? Okay. So that is why this concept of critical zone came, that you measure, monitor, model everything in a single place. That is the top of canopy to the bottom of the aquifer. So like I said, this study is initiated like 20 years back. You can see there are several critical zone observatories, majorly in the US and the European countries. And then there are some observatories in the tropical regions, like in some in Africa, India, and then Thailand, Laos, etc. Okay. So, but if you look at the tropical regions, there are relatively few CZOs, I mean critical zone observatories, that is the stations where we monitor all these critical zone processes as compared to the temperate regions. Okay. Even though these tropical regions are like dominated by monsoon and the temperature change is very like large scale heterogeneity in the temperature, which favorite accelerated change, there are very limited observatories in the tropical regions. Okay. So for example, if you see the, for example, in France, France is what, like a size of probably Tamil Nadu. They have several critical zone observatories, at least 15 of them in different environmental gradients. Okay, well, in environmental gradients mean it is like you bring climate, rainfall, temperature into picture, you bring land use into picture, you bring geology into picture, and geomorphology, terrain characteristic, everything. So there are different environmental gradients in a watershed, and they are monitoring or setting up observatories in different kind of monitoring systems. So in India also, like in the first observatory in India is in Kamini Observatory, which started in 2005-6 times, and then there are several observatories which has been initiated after 2016. So at NSES where I work, we created 3 observatories, critical zone observatories. One is in Attapadi, this is the Upper Bhavane region. Another one is in Munnar, this is the Periyar and Amaravati river basins. And in Adurai, which is the Kaveri, distributor of the Kaveri we worked in collaboration with Tamil Nadu Rice Research Institute. Okay. So the idea here is like you model and monitor, observe, monitor and model many of the processes at the same observatory. So why we choose these 3 observatories? Because of the environmental gradients that exist in this observatory. You have Attapadi, which is a kind of subhumid to semi-arid transition zone. You have Munnar, which is a humid zone, high altitude mountainous humid zone, and then you have Adurai, which is like a deltaic region, tropical wet and dry climatic system. Okay. So this is how an observatory look like. So you heavily instrument the watershed. You select a watershed and you do instrument it heavily. This is a snapshot from our Attapadi Palakkad Observatory, where you have measurement of atmospheric variables, that meteorological variables. You have lysimeters to measure the soil water movement. You have eddy covariance towers to measure the evapotranspiration. Then you have soil moisture sensors, you have groundwater level sensors, you have stream flow sensors. And then there is canopy measurements like LAA, biomass, NDVA, those kind of measurements. So all these things are measured at the same observatory. So you will have a closure there. I mean, all the measurements are made, you can model and then upgrade it to a higher scale. I mean, upscale it to next level. So I talked about the basic differences between the 3, whether it is geomorphology, geology, I mean lithology, or the landscape or land use or the climate. All these are different in the 3 different zones. That is why we choose these places. So once you have an understanding at one watershed, we can upscale the understanding and modeling our processes to a different scale. So this is the kind of the monitoring stations examples we have set up in the observatories. See, all these things are made like to answer the questions that we have posed before, like what kind of changes is taking place in the hydrological cycle and what kind of changes is taking place between the surface water, subsurface water interaction. To understand this process, we have instrumented the observatories. We have set up also some experimental laboratories in the institute. So these are some of the experiments. We are doing soil characterization. We are doing some modeling and inverse modeling to estimate the soil hydraulic properties. We are looking at the groundwater and surface water chemistry. This is the stream water chemistry and how they are related. Another concept we are looking at is the concept of critical zone from space, because I talked about upscaling the processes from a smaller scale to a larger scale. For this, you need to have like remote sensing data is one, but then you need ground measurements to upscale anything. So we have set up several soil moisture sensors and evapotranspiration sensors, etc. So our observatories are a part of this, NASA ISRO synthetic aperture radar mission, which is going to be launched in February. Our 3 CSOs are calibration validation sites for soil moisture, and then again it will be for Trishna mission on evapotranspiration as well. Okay. So I will end with these questions. This is not a summary, but the kind of questions probably some of you also can work on to see, because there is large data set, open data set that is available in India, and then the modeling tools like SWAT, Flow, etc. that is already available. Some of you can take up this question and see what kind of research you can do. For example, how does changing rainfall characteristics? See, by character, we are normally looking only at the quantity of the rainfall, but there are several other factors in rainfall. For example, the number of days of rainfall. How many days rainfall is taking place? Okay. Then the spells, like continuously how many days of rainfall greater than 2.5. So these are called as like prolonged wet spell, dry spell, or wet spell, dry spell. Then there is something called seasonality. There is something called intensity. So there are several characteristics which play a role in the runoff and groundwater recharge process. Okay, not just the quantity of the rainfall. Most of us use the daily rainfall data, but then if you look at the number of days of rainfall, the spells, etc., those will tell a different story on the recharge and groundwater process. Then second is how like integrated models can be effectively used to study the feedbacks and interaction between the hydrological system. I told the examples of, for example, SWAT mod flow. There is a hydrous mod flow. Hydrous is a Wadowstone model. So how we can go from using a single model, like for example, independently using SWAT or independently using mod flow, now come together and work with a SWAT mod flow to see how we can understand the process better in an integrated model. The third one is the first one, which I talked about, the acceleration of the hydrological cycle. So this also can be easily identified. You have the data set, you look at the data set, you see what kind of change is taking place. But like I said, you should be very careful about the length of the data. If you use 100 or 120-year data, you may not see the signal. You have to break down the data set and see, like there is something called as change point or regime change. So at some point, there will be a crossover between two time series. That means there is a shift in for example, if you look at the stream flow, if there is a dam construction, from the point of dam construction, the flow will have a different pattern as compared to the time before. So that is a regime change. So the same kind of regime change is there for rainfall or any meteorological variables. Okay, so you can identify from which point of the time there is a change in regime and how it has changed, whether it is accelerated or decelerated, those kind of things. When we talked about all this water quantity aspect, there is also this water quality aspect, like again the same, like when with the different rainfall characteristics, how does the solute transport take place? So all the solute in the groundwater system is coming from the weathering process in the rock weathering converts to soil, and all these mineral are transported to the groundwater system. So with this change in the rainfall characteristics, how does the solute transport mechanism changes? So that is one question you can answer. That's all. Thank you. If there are any questions, I can answer.
Talking about the water loss, calculating the water loss, you have very well pointed out the loss due to snow storage and all. That is in the northern part of India. That also should be taken into account. Is it not that important to calculate the water loss due to soil moisture or soil observation? That is also equally important, no?
Yes, that we are taking into account as evapotranspiration, because surface soil moisture, whatever loss is taking, it is going as evapotranspiration, at least the top 15 centimeter. That is evapotranspiration.
Evapotranspiration,
yes.
You have very well pointed out,
yes.
and that is different case. But soil moisture will be retained there within the soil for longer duration, no?
Yes, sir.
Not only the surface soil I'm talking about. If soil layer is of this and this zones or different layers of the soil is there, means water loss will be definitely there.
Yes, sir. Yes.
Are we taking steps to calculate those?
Yes, sir. See, one major difficulty in going for subsurface soil moisture is that we don't have any satellite mission that is providing subsurface. Okay. So in the NISR mission, that is the NASA ISRO synthetic aperture radar, which will be launched in February, one of the science program is on estimation of these root zones up to 1 meter soil moisture. So we have instrumented the 3 observatories. I mentioned 3 observatories with measurements of 1 meter. So we installed like 3 months back. We are now generating the data of subsurface soil moisture for this one. And then we use the NISR data set to make it spatial. So we will have an understanding of, like what you asked, what kind of changes will take place or what is taking place in the subsurface soil moisture. Surface soil moisture is very easy to understand, direct connection with the rainfall.
And
but
if you could consider those subsurface soil moisture loss also,
yes, sir,
the results will be much
moving.
better to go for
yes,
precise results.
Yes.
And also, there will be observation due to vegetation.
Yes,
Also.
sir. Yes, sir.
So, in any point of research, if maximum possible integration can be done, that would be better for
we do
bringing out sustainable development.
We do vegetation water content, like biomass,
nice.
and then see what kind of water was available in the plant. But then this can be done at very small scale. Okay. In a forested region, you can't really measure get a good estimate of biomass. But then again, in this NISR mission, there is a component of biomass estimation. So that if we are able to incorporate that biomass or vegetation water component into the model, then the system will be whole.
And if I'm right, I think we'll be able to get the data through remote sensing that vegetative cover moisture, no, vegetation moisture, from season to season, daily basis we are getting, but season to season, if you are able to compare that, we may end up with better
Yes, sir.
results.
The NSR mission has a lot of scope, like because they are promising to give it 100-meter resolution, 100 meter by 100 meter.
That
So if
will
you are
be
able
better.
to, I mean, this is a promised one. The launch is in February 25, and maybe after 3 months by April or May, we should be able to get data. So if that is available, then much of these questions can be addressed. I mean, at least at India scale. Yes, sir. So,
Thank you.
thank you, sir.
What about the rejuvenation of rivers and interlinking of the tanks and
I haven't, I mean, worked on anything on that. I look at small scale, but rejuvenation is like the main thing we looked at is the base flow. Like we are doing a, I mean, detailed research on the why this base flow is reducing, because many of the rivers has dried down in the summer season. Once where there was continuous flow, even though we don't have any snow melt or anything in the southern part of India, but still there was a continuous flow in the river even during the dry season. But this has reduced drastically. So if you have read in news, like there are many regions where they are removing the eucalyptus acacia plantations. So one rubber plantation, eucalyptus and acacia, that is like non-traditional, or those plantations are, they are not in original. So these three crops are known to pump out a lot of water from the groundwater system. They take a lot of water out of the system. Acacia has a kind of fibrous root system that doesn't allow water to percolate too much into the system. So if you look at Munnar last 2-3 years, they are cutting down all the eucalyptus trees, removing all the eucalyptus trees from there. It's a court order that should be removed from there, because that is pumping a lot of groundwater from the system there. Okay, so that is one thing, that we are losing the groundwater because of evapotranspiration.
so another task is our international seminar aim is sedimentation. So the major problem is rivers is sedimentation
Yes.
losses. Why? Because sand traveling, commercialization. How to protect our department?
In Kerala, maybe 15 years back, they stopped this river sand mining. There was, I mean, that legislation was made from our institute to cut down or stop all the sand mining. In entire Kerala, there is no sand mining now. Okay. So that is why all the materials are being transported from Tamil Nadu to Kerala for road construction or anything. Okay. So there has been a law that there will not be, I mean, except for reservoir sedimentation they remove, but not the river. But then this also have an adverse effect. Over the years, river has become shallower. So the flood water, I mean, river is not able to hold the flood water anymore. It is, inundation is higher actually. So there should be some balance between sedimentation and the kind of thing that we have to remove, desilting from the rivers. So currently there is no removal of sand, but then there should be some judicious way to take some sand out of the system so that flood water can be held in the river channel itself.
So another major drawback is Indian government announced. So there is a major drawback is one of the thing is the loss of the sediments, as well as there is no proper system interlinking of the rivers, but also the water is depending upon the threatening of the industrial waste and other things. The temperature is high. Entire water goes to above the surface. That is a reverse. That is the Wayanad effect also same thing.
Yes, sir.
So the water is always go to the ozone layer.
Yes, sir.
And then immediately depending upon the temperature suddenly rise
falls,
the
yes.
rainfall.
Yes, sir.
So that is the major effect of the Wayanad effect also,
Yeah,
and Chennai also.
Yes, sir. I mean, many, even like Spain, you can say that heavy rainfall was there. That is like I am saying that that acceleration of hydrological cycle, we are increasing the atmospheric moisture. So then suddenly there will be heavy rainfall at one point of time, everything pours down at one point of time. Then again, this was not the case like probably 10 years back. This has become more frequent now.
What about the young scientists? What is our role? What is the opinion of the young scientists and
See, some of
ideology?
the
How
things,
to enlighten the people, rural people and urban people?
see, some of the things like, for example, climate change, it cannot be controlled in a short period of time. We will not be able to control the rise in temperature or any of these kind of things in a short period of time. But The only thing is for us to do now, I mean, the shortest thing to do is like we always have advised to keep the drainage free. Like we look at the big rivers, but then there are like first order stream, second order stream, third order, all these connect to become a big stream. So keep this drainage always open. For example, in Wayanad or the landslides before we have visited at some places, many of these places, the first order channels or second order channels has been blocked. I mean, they construct houses, etc., because there are no water in the dry season. So they assume it is nothing and then they put. So the water is unable to come to the channel. Everything goes inside the soil. Soil gets heavy and then everything slides down. This is one we always say that drainage should be kept free. You should not block that one. And then, okay, probably that's one.
So good morning, sir. It was a wonderful presentation, sir. Sir, I have a doubt. While you are doing modeling for the coastal regions, sir, there is a phenomenon called as submarine groundwater discharge, where there is a significant amount of groundwater getting discharged into the ocean through the subsurface. So have you taken into account during the modeling?
Yes, I mean, see, actually we do. Selvam sir is here. So I told Selvam sir I will not speak about submarine groundwater discharge because we both are doing the same thing. Okay. So I have two projects. One is what I talked about. The other project is on the submarine groundwater discharge. We're looking at the east and west coast of India to see what kind of water is going as submarine into the ocean. Like the idea is to see the daily variation of the flow that is taking place to the ocean, and then see at what point how much water can be sustainably extracted to feed the freshwater demands of the coastal zones. But then there is another point of this, because this submarine groundwater discharge is carrying a lot of nutrients to the ocean that is driving the ocean ecosystem, that is fishes or whatever it is. So if you pump out this water, what effect will that have in the coastal ecosystem? That is another question that needs to be answered. So currently we are looking at, I mean, during the last 4 or 5 years, we identified together with Professor Selvam, Professor Anthony from here, and then there are several other institutes. We have marked the places where there is potential groundwater flow into the ocean. There is potential STD zones. We have already marked that zones. I can say roughly 22% of the Indian coast, something like 1,000 kilometers square of Indian coast is having perennial STD into the ocean. Okay. But the next question is like, what is the volume of water going? Not on an annual basis, because you tell an annual quantity that is of no use to anyone. You need to know the daily variation, like in what season or what day you can pick out the water. I mean, this is still it varies with season, rainfall, etc. But we need to know what is the volume of water that can be sustainably extracted. So one thing we are doing is this modeling. Jesuraj is here. He's working at in our institute. He's from here. He's looking at the radon mass balance kind of things. So we are working towards that, but the quantification is a little tricky.
Because since there are like multiple layers of aquifers, so the quantification of those water which will like enter into the...
We discussed this once, like we can do like shallow aquifer. Okay. We cannot go deep. There are two things. One is the effort needed to quantify the volume in a deeper aquifer, because probably these all are discharging into in continental shelves.
Yes.
You cannot go there and, I mean, still, I mean, probably NIO can do some ship and then do the things. But see, when you go deeper and deeper, you are having a lot of like weight, overburden pressure. The porosity will be less and the flow will be much slower as compared to what is happening in the shallow aquifers. So the question is the effort that is required to quantify or study the deep process, confined aquifer process, may not be like economically quite good. We can't be going to continental shelf to pump out the water. Okay. Just for a science question, you can always go and do kind of things. But being a government institute, we need to look at the benefits of that to the society. Okay. So we are not planning to go for the deeper ones. We are looking at the shallow aquifers and to see how much water can be taken out. Yes.
Thank you, sir.
Yes.
So how to identify those zones?
No, there is nothing like identification. Like I said that there are different environmental gradients. One is this climate. You have this humid, subhumid, semi-arid, those kind of transitions. So for example, if you take this Palakkad or Tapadi where we took, one side is this Island Valley, that is high mountains, that is a humid region. And then slowly you have a subhumid and a semi-arid. So there is a climatic transition within a watershed. So you will be able to understand a process in 3 different climatic zones. And if you look at lithology, then it is again complex lithology there. You have different geological terrains in that region. Geomorphology is also different, and then land use. So all these, if you could bring all these together in a watershed, then you can pick it as a critical zone thing. But again, you don't want to repeat the same thing in 2 places. That's why we have 3 different characteristic in 3 different observatories.
Thank you, sir.
Thank you, sir.
Most of the Kerala rivers are in the shallow depth river. What will be the positive or negative impact for the banning the river sand mining?
See, what I always felt is that the channel capacity has reduced because over the years sedimentation has come and it has filled the river beds. I mean, you can see the river channel has become shallower. Okay. So, and then with the very high rainfall, the channel is not able to take the water. It is overspilling and creating a lot of flood. So that is one negative I felt, that there should be some mechanism to remove some, at least some part of the sand, to bring the, to increase the volume of water that a river system can take. Because we already occupied all the floodplains. There are no more floodplains because everything is already occupied by people. The only way now to do something with the river is to take some sand out of that so that you can increase the volume. So at least you can protect some regions from inundation. That's all.
Being you are working in the being your state government authority, now you have to suggest to remove to some extent to the sand in the river bank.
Yes, sir. I mean, we until 2014 we were with the state government. That time all this happened, and after that we are with the central government. So now we have limited role. But there, I understand that there are some efforts to remove sand from Bharatapuzha River, central Kerala. Okay, so there are some things. Reservoir desilting is already taking place, but there are some like Dam Safety Authority and Riverbed Authority. There are some agencies there. We are also a partner, we are kind of advisory partners there. So there are some things that is going on, but it's not like, because there are a lot of environmental activities that come into play with these things. So it takes some time, but it will happen.
Thank you, sir.
Thank you, sir. So thank you all for listening to me. Thank you.
Thank you, sir, for your knowledgeable words. It's very admirable. Thank you, sir. Now it's time to start up with the online session of today's participants. I kindly welcome the chairpersons of today's online session, Dr. K. Srilash, sir, Scientist D, Hydrology Group, National Center for Earth Science Studies, Kerala. Dr. G. Muthishankar, sir, Head of GIS Projects, French Institute of Pondicherry, and Dr. D. Manimaran, sir, Associate Professor in Geology, V.O.CHIDAMBARAM College. Welcome, sir.
Good morning, everyone. We will start the session 1 of day 2. So, understand that the second presenter, Nimlan Veerasamy, is available online. So, he will be talking about tracing radioactive mineral dust. And Nimlan, your time is like 10 minutes. So, stick on to the time because we have a lot of presentations lined up. Okay, so we will stick with 7 minutes of presentation and 3 minutes of discussion. Okay, so
Yeah.
don't go too much into the introduction. Just briefly introduce and go further. Okay.
Yeah, sure. So, am I audible now?
Yes, yes, you can share your presentation.
Okay, thank you. Is my slides visible now?
Yeah, it's now okay.
Yeah.
Can you change the presentation mode?
Yeah, please. Okay. Yeah, I think it's in presentation mode. So shall I start now?
Okay, you can start, please.
Okay. Vanakkam and good morning to everyone. I'm Nimlan Veerasamy, currently working as a William E. Postdoctoral Fellow at Department of Geological Sciences in Queen's University, Canada, and also like visiting researcher of Tokyo Metropolitan University. Before starting my talk, I would like to thank organizers of this conference, Dr. Selvam and Dr. Rajamanikam for inviting me to this conference to present one of my research. And today I'm going to talk about like tracing radioactive mineral dust, establishing a baseline strontium isotope ratio in Gopalpur, Chhatrapur, Odisha. So I would like to acknowledge my supervisors and seniors who were actively involved in this research. And I would like to thank Tokyo Metropolitan Government for funding this research as well. So flow of this presentation would be, first, I'm going to talk about natural gamma radiation survey in high natural background radiation area of Odisha in India. And then followed by, I'm going to talk about like significance of strontium isotope ratios and then measurement of strontium isotope ratios in HBRA samples. And finally, like I'm going to discuss about an approach to trace radioactive mineral dust using strontium isotope ratios. So India is one of the countries have large amount of heavy mineral deposits in its coastal line, especially monazite, ilmenite, rutile, and zircon deposits in the certain regions. For example, Gopalpur is my study area. Today I'm going to talk about. Because of the enormous deposits of monazite, certain areas in India are called as high natural background radiation areas. The first high background radiation area has been found in Kerala, then followed by the studies has been done in Tamil Nadu, and recently like people have started studying in Odisha. So my research mainly based on like Odisha. So this map shows the study area of Chhatrapur Gopalpur coastal region, which has high placer deposits. This study area covers 20 kilometer distance and 2 kilometer wide, and it covers like 20 villages close to the mining. Due to the enormous deposits of heavy minerals, Indian Rare Earth Element Limited started mining there, and it is actively mining is going on now. This slide shows the occurrence of monazite sands in the study area. We have observed heavy mineral deposits as a layered form and then patches as well as like disseminated form. And we did like gamma dose rate surveys in the beach. You can see the dose rate along the beaches ranges from 0.7 to 2 microsievert per hour, which is quite high compared to the worldwide average. And from here, like I'm going to talk about the survey of full gamma radiation survey in the coastal villages. We have done about 20 residential areas of gamma radiation survey. We used carbon radiation survey technique to measure external gamma radiations in this region. We used 3 into 3-inch sodium iodide scintillation gamma spectrometer, which is this. And we kept this detector in the car about like 1 meter height from the ground surface, and the car was drove around like 40 kilometer per hour speed, and every 2 minutes continuously we monitor the gamma pulses. And the beauty of the instrument is we can able to measure ambient gamma dose rate in the outside in field. It gives the gamma pulses. So at the same time, we can able to check the dose rate of gamma as well as the radionuclides, which is corresponds to the gamma radiation. For example, uranium, thorium, and 40 potassium. So this is our survey route. We mainly focused on the coastal region. In order to check what is the control, we went to like city and little bit away from the survey area. So the red points and blue points are the fixed stations where we measured gamma radiation pulses for longer time. Let me say like 10 minutes. And this is the results of gamma radiation survey. You can see this map. Along the coast, we can see the high gamma dose rate. And when we move towards the inland, we can see relatively less gamma dose rate, even though if it is less, but it is still higher than the worldwide average value. And then the statistical analysis shows us the clear gamma dose rate distribution from inland as well as seaside. This result is the observed dose rate we have measured from every residential areas in the study area. The highest gamma dose rate observed in the Badaputi, which is close to the mining site where they're dumping the tails. And the lowest was observed in Kalyapalli, which is little bit away from the mining site close to the lake. So overall dose rate is higher than the worldwide value and scale. So this is the activity concentration of uranium, thorium, and potassium in air collected from the sodium iodide scintillation spectrometer. The mean of potassium and uranium and thorium is higher than worldwide value as well as Indian mean value. So during our field work, we have observed the mineral dust in every residential area, and we have spotted high gamma dose rates in certain dwellings. So we decided to collect air particulate matters and measure the radioactivity from the air particulate matters. And I'm interested to trace the source and delineate source from the urban dust as well as alien dust from the radioactive mineral dust. So further, like I was thinking to do like strontium isotope ratio to trace the source of radioactive mineral dust from high background radiation area.
7 minutes
This
is
graph shows.
Milan?
Hello.
Yeah, your 7 minutes is done. So make it fast.
Yeah, I can wrap it up fast if you don't mind.
Yeah, please.
Yeah, this is a schematic diagram how strontium isotope ratio is used to find the source and transportation from one place to another place. So the strontium isotope ratios, we measured, this is the methodology. We collected the sample based on gamma dose and we used micro digestion, and we measured the strontium concentration using ICP-MS, and then we processed chemical separation. After chemical separation, the recovery was checked with ICP-MS. Then the isotope ratios were measured with TIMS, thermal ionization mass spectrometer. So this slide shows the results of our strontium isotope ratio. In left graph, you can see our ratios varies from like around 0.73 to 0.81, which reflects the granitic composition and as well as like mineralized sediment. This result is very well correlated with our like uranium isotope studies, which were published in Chemosphere 2023. And this is the isotope signatures of monoxide. Like I want to know like where it falls versus inverse strontium concentration. You can see the mineralized, I mean like monoxide isotope ratios as well as the mineralized sediment isotope ratios are mixtures, and some of my samples are following in granitic, Archean granitic region. So this is the future direction. Like I would like to measure air particulate matter and measure the strontium isotope ratios from the air particulate matter, try to correlate with the monazite sands. It may give the insight of delineating trace. And I would like to do isotope mix model using source rock as one N member, and then urban dust, alien dust, and smoke dust as a N member of the isotope mix model to delineate like what type of dusts are contributing high radioactive in this study area. Thank you for your kind attention. Yeah, and sorry about the time.
That's okay. So we will have time for like one question. So
Any question from audience? So, did you find any health issues in that area? No, because the big
Yeah,
problem.
we have done health impact studies as well. We have done like radiological health impacts as well as heavy metal health impacts. For me, like it's a high background radiation zone, and other like radon and thoron studies have been done. People have suggested that it needs like regular monitoring in case of like radiological impacts as well as like low dose effects. And um, then the group of research scientists, they are proposing there should be some cancer related research has to be done in this study to understand the biological effects of high radiation. Yeah, we have done the primary studies, yes.
Thank you.
thank you, Nilam. You can.
My pleasure.
Yeah, thank you. You can stop sharing.
Yeah, thank you so much.
So now the first presentation, Tennerisan Nadarajan, assessment of uranium contamination. So, Tennerisan Nadarajan, you can join.
Hello, am I audible?
Yes. Yeah, you can share your presentation.
Is my presentation seen?
It's coming up. Yes, yes. Yes, so Tennerisan, you have like 7 minutes of presentation and we will have 3 minutes of discussion, okay?
Okay,
So
thank you.
please stick on the time.
Yes. Good morning, everyone. Myself, Tennerisan Nadarajan. I'm a recent PhD graduate and a visiting researcher at the Department of Radiological Sciences, Tokyo Metropolitan University. And my presentation is on the topic assessment of uranium contamination in groundwaters of Southwest Punjab and insights from soil geochemistry. This will be the outline of my presentation, where I'll be starting with the introduction, and moving on to the study area, methodology, results, and finally I will conclude with summary. Uranium contamination in the southwest regions of Punjab, especially in the groundwaters, have been on the spotlight for almost a decade. And uranium is one of the heaviest radioactive element on Earth, and chronic exposure to uranium radionuclides present in drinking water poses potential risk to human health. And this is the exposure pathways of various exposure pathways of uranium to human. And if it gets accumulated in the human body, it may lead to several health effects such as kidney damage, lung cancer, and a few others. These are some of the background studies from Punjab region, which is located near the capital of India and has high uranium content in the groundwater. According to the World Health Organization, the permissible limit of uranium is 30 microgram per liter. And according to Atomic Energy Regulatory Board of India, the permissible limit of uranium in drinking water is 60 microgram per liter, whereas almost most of the samples, almost above 80% of the samples from the southwest region of Punjab tend to show high concentrations above than 30 as well as 60 microgram per liter. The positive correlation of uranium with the bicarbonate shows that the uranium is getting leached and then leached from the surrounding aquifer and getting accumulated in the water, whereas the bivariate plot of uranium against oxygen isotopes suggests that there are two different sources that is contributing uranium to the groundwater. This is the geological map of study area, Bathinda, which is located at the southwest part of Punjab. It is predominantly composed of Indo-Gangetic alluvium, and the Bathinda is mostly composed of oxidized silt clay with conker and micaceous sand. So we have collected groundwater samples from Bathinda as well as Mansard districts, and soil samples from limiting to the Bathinda district only. So during the sample collection, we also measured the water parameters such as pH as well as TDS in the field itself. So the collected water samples were pre-concentrated to 100 ml, and the trace elements, including rare earth elements as well as uranium concentrations, were determined using the inductively coupled plasma mass spectrometer. Our certified reference material, SLRS-6 river water supplied by the NRC Canada, was used to validate the method. And the soil samples were digested using various mixtures of hydrofluoric acid, nitric acid, and perchloric acid in a microwave digestion system. The certified reference material, Japan Lake sediment supplied by the Geological Survey of Japan, was used for the analytical validation. And here we can see the recovery of rare earth elements was found to be above 90% for the certified reference material. Moving on to results and discussion, the uranium concentration in the Bathinda and Mansa districts were varied between 7.36 to 1000, nearly 1000 microgram per liter, with a mean of nearly 140 microgram per liter. And the mean was found to be above the WHO permissible limit as well as Atomic Energy Regulatory Board permissible limit of 30 and 60 microgram per liter. However, most of the groundwater samples from shallow aquifers showed high concentrations of uranium when compared to the deep aquifers. In our study, the uranium did not show any correlation with the pH, water parameters such as pH as well as TDS. Along with uranium, other heavy metals such as chromium, copper, lead, iron, nickel, and zinc were also studied, whereas all of them were found to be under the permissible limit of World Health Organization. Using the uranium concentrations, we determine the radiological risk as well as chemical risk. The radiological risk associated with uranium exposure through drinking water was studied by the excess cancer risk, and it was found to be higher than the World Health Organization limit recommended value, and under the limits of Atomic Energy Regulatory Board recommended value. Whereas the chemical risk assessment was done using the lifetime average daily dose, and it was calculated using this formula. And the hazard quotient was found to be above 1, suggesting that there is a possibility for non-carcinogenic health related to uranium in this area. The rare earth elements were also determined in few groundwater samples, and using the rare earth elements, we can able to understand the oxic and reduction condition. For most of the samples, the cerium anomaly was found to be less than 1, suggesting an oxic environment, and under which the uranium will occur as a uranyl and it will be in soluble form in the water. And it was also supported by the other redox sensitive trace elements such as iron and manganese. Especially for a few samples, the manganese concentration was found to be high, whereas the uranium concentration was found to be less, suggesting an reducing condition in which the uranium will get deposited. As it was reported that most of the shallow...
Your 7 minutes is over, so make it faster, okay?
Yes. Sorry. As it was reported that most of the shallow aquifers tend to show high concentrations of uranium. We also have done carbon survey, as it was explained in the previous presentations. And we found that the activity concentrations of 226 radium in the uranium series and 232 thorium and 40 potassium were in the world average values recommended by the UNSCARE. We have also done the soil geochemistry, and the thorium by uranium ratio suggested a uranium loss in the soil, whereas the nature of soil was found to be felsic, and since they are alluvium, the source rock might have formed in a continental island setting, which was supported by the lanthanum thorium scandium triplot. These are the summaries of this study, where the uranium concentration was found to be higher than the permissible limit, and the risk assessment such as excess cancer risk and that question indicates possibilities of carcinogenic and non-carcinogenic health risk associated with the intake of these groundwaters. And the gamma spectrometric study was helpful in assessing the ambient dose rate of Bathinda, and the activity concentrations of primordial radionuclides were found to be less than the world average values. The uranium concentration in the Bathinda soils were close to upper continental crustal value. However, the thorium by uranium ratio suggested a possible removal of uranium under oxidizing condition. Further, the trace element geochemistry helped in soil source determination. Thank you.
Thank you, Tennyson. Like, we will have probably a couple of questions.
Yes.
Any questions from audience?
Yes, sir.
One question from answer. This is a source for the uranium is the geogenic or any external resources, sir? For the uranium, all the contaminations.
Yes, sir.
Is the geogenic one?
Yes. So actually, there are studies which support that the source for uranium is geogenic. However, there are also studies which are showing that the uranium in the groundwater samples shows a positive correlation with the NPK fertilizers, such as uranium shows a positive correlation with nitrate, phosphate, as well as potassium from this region. However, it was also reported that due to over exploitation of the groundwater for the irrigation purposes, the aquifer is becoming oxidized. So under oxidizing condition, the uranium will get leached from the aquifer and gets accumulated in the groundwater in the soluble form. So these are the possible reasons that could support the source of uranium in this area. However, we can really understand the source of uranium by doing the uranium isotope ratio studies, which we plan to do in the future.
Okay, that's good. Any more questions from audience? Yeah, please.
Thank you, Tenderson, for your nice presentation.
Thank you very much for the opportunity.
You can stop sharing. We'll have the third presentation. This will be by Gurudev. Presentation is on 2 decades of shoreline mitigation in Trivandrum district, Kerala, and impacts of climate change. So, Gurudev, you can join and share your presentation, please. Yeah, Gurudev, you can join, please. Make it full screen. Can you speak something? We are unable to hear you. Gurudev, am I audible?
Okay, sir. Can you hear me?
Yes, yes. Make it full screen. So you have 7 minutes of presentation and 3 minutes of discussion. So please stick on the time. At the end of 7 minutes, I will give you a message, okay?
Definitely, sir. Okay, is it full screen, sir? Is it?
Not yet, not yet. You can go ahead. No need to waste time. You can move forward.
So I'm going to present the 2 decades of shoreline migration in Trivandrum district and impact due to climate change and coastal construction. So first of all, the issue of shoreline migration is currently becoming a threat in the state of Kerala and around in the world also. So it's mainly a threat for like environmental issue and the social economic issues. And I have identified many problems due to this issue.
Like we are still seeing the first slide.
Actually, I'm presenting, sir. Sir, I don't.
Yeah, I mean, probably you can share entire window and open your PPT.
Okay, sir.
Or entire screen and share your PPT.
Okay, sir. In the actually, sorry, the screen I can't.
There's an option, no, share screen. Do that and then open the PPT.
I'm doing it, sir, but it's becoming it's mirroring, sir. Now, sir.
Make it full screen.
This presentation mode you can choose.
That I'm doing, but Google Meet it is a bit difficult. Sir, anyway, can I,
You can go ahead, just
sir,
second slide. Now we are seeing the first slide.
second slide, can you see now, sir?
No, we are still in the, like before, but you can go ahead because we are wasting time now.
Yes, sir, okay, sir. Actually, mm, sir, first of all, it's the climate, the shoreline migration is mainly due to the two things that I observed. It's due to the climatic change and is accompanied by the increased coastal constructions in recent years and the lack of maintenance of the coastal construction. And the study also addresses the 2 decades of coastal change in Trivandrum district. And we spotted the erosion prone areas and determined the eroded coastal length also. So, so the study area covers the 78-kilometer long of coastal zone in Trivandrum district, one of the southwest coast of India. And the coast is characterized, the Trivandrum coast is characterized by the high energy, highest wave activity and high steep beach face also. And the methodology we employed is based on remote sensing and GIS techniques. And we use the multi-data Google Earth images, which is realized in Google Earth Pro and QGIS version. And the comparison of coastlines across different time intervals that identify and the zones of accretion and erosion were calculated. And mainly the impact for the shoreline migration in Trivandrum district is due to two factors. One is the climate change, and second is the impact of coastal constructions. First, going on to the first, the impact of climate change. So the coast of Kerala and Trivandrum is mainly observed as a seasonal trend in deposition in summer, deposition in summer and erosion during the monsoon. And the area is characterized by alternating deposition and erosion periods with nearly a 5-year interval. And for this, from 2015 to nowadays, there is the unusual warming of the Arabian Sea and the high sea surface temperature. It has intensified the cyclone activity in the Arabian Sea. And from the one publication by Roxyam, it is said that a 9 degree of rise in sea surface temperature leads to a 2 millimeter per day increase in rainfall. So from if you observe from 2015, the Arabian Sea has witnessed more number of cyclone routes to increase sea surface temperature. Severe strong cyclonic activities were reported from 2015. Mainly, it started from 2017 from the Oki in November 2017. And so, if the trend is going continuously, like warming is going on continuously, we may find many cyclonic activities in near future. So, and the next one is the impact of coastal construction. So, in Trivandrum, Delhi, mainly the Vizhinjam International Seaport and the many breakwater constructions, that is for mainly fishing and all the others have been constructed. Around these two coastal construction, one is Mudapuri and the second is the Vizhinjam International Seaport. This shifted the high energy waves towards the nearby unprotected beaches and resulting in their erosion. And the breakwaters, the breakwaters also disrupted the longshore sediment transport, and it leads to the intense wave activity and erosion on. That is a particular feature. Wherever the breakwaters of the seaports are constructed, the northern side always faces severe erosion, and the sediment will be accumulated on the southern side of the construction. So if you go another major and multi-common unable to present. I could show that. So the sediment accumulation is on the southern side. If you observe the William Seaport Limited, and second one is the trend of deposition and erosion. In the summertime, the sediment transportation is along the northern part, and it shifts during the monsoon, and the sediment transport will shift towards the south. If the dredging is continuously going and all and going on, the sediment will definitely fall into the dredge site and thereby destroying the beach creation process. And therefore, there will be no beach will be formed during the monsoon time as the sediments are accumulated or it's going on to the dredge basin. That's one of the main factors. And finally, we have identified the erosion hotspot. Mainly in Trivandrum, the main erosion hotspots are categorized into 4 sectors. Mainly the Mudalapalli sector, Shangamuham, Bhimavalli Valiyadura, and Vizhinjam Kundra. These are the main erosional hotspots in Trivandrum. And coming to the conclusion, we can see almost uh, 20 percentage of the area has been eroded away out of the 78 kilometers coastline from 2003 to 2024. It's mainly 20.12 percentage. And many parts, as I said, the northern part of the any coastal construction is facing severe erosion, and the southern part is showing the accretion. So for that, the main problem is that the lack of maintenance of the structures, like for example, for a seawall and other coastal protection structures, is highly they are lacking the maintenance. The lack of maintenance is the main portion for triggering the high wave activity also. So I am suggesting mainly the installation of geotubes and maintenance and the installation of seawalls in the targeted area for the erosion hotspot, coupled with the proper management and regular maintenance, as this has to be proven to be effective. And another national solution includes the planting of mangroves in different parts of the coast, and it will help to stabilize shorelines and reduce erosion. Okay, sir. These are my presentation, sir. Hello.
Yeah, thank you, Gurdeep, for sticking on to the time. I have a question first. Like you mentioned about impact of climate change and coastal construction. So, which do you think play a significant role in shoreline migration in Kerala?
Good question, sir. So first of all, that the coastal construction, if you observe in every, majorly it is sea surface for the climatic factor. Majorly, the increase in sea surface, that is a pivotal role. And if you observe the coastal construction also, the main erosive hotspots that are coming due to the breakwater construction and the seaport limited, there is a main factor. The wave activity will be high in the northern side.
Okay. So
I would say like a 60-40 maybe, like that.
Any more questions?
Any more questions from audience?
Thank you, Gurdeep. Thank you for a nice presentation. Can stop.
I'm really sorry for the I couldn't.
That's okay. That's okay. We could able to see your presentation. Thank you.
Thank you, sir.
So I understand that others are not available online. So we conclude this session. So we have 3 presentations. Two of them are on, one of them is radioactive mineral dust in Orissa, another one is uranium contamination in groundwater in Punjab, and then from Kerala about shoreline migration due to climate change and coastal construction. So thank you all for joining this session. We'll join the next session. Thank you.
Now, I kindly invite Dr. Selvam sir to honor Dr. Bahati Shabani Zaimana sir, University of Rwanda, to honor with shawl, memento, and certificate.
from globally in the context, we see there is something are happening when the UN Environmental Program Protection has announced that there is something has been changed. When you see, according to World Economic Forum, the ozone layer is the light path to recover. He has showed the way the world is make it. I want to show one video, small video, then you see there is something we are doing, then I will talk later about that. So as you see, there is some change happening for greenhouse gas emissions for ozone layer. And you see when you see from here, in 98, there was more than 1.2 million tons was emitted. But when you see the change, there is some radical change happening through the emissions. So this is a big picture showing is that these sustainable development goals is happening, is making something which is better. Because this is happening due to reduction of greenhouse emission and the cycle economy are implemented in different industries and through development key stakeholders, and also adoption of renewable energy. This is two significant important reduction of this emission. And they are expecting that in 2040, so our ozone layer to be recovered. So once we continue to collaborate with all stakeholders like companies and individuals, we can make significant achievement for our ozone layer to be recovered. So my key points, I want to talk to like key stakeholders in bridging the SDG gap, regulatory framework, and also current state and the challenges, and the like case studies with call to actions. So when you are going to sustainable development goals, something we should know that it's a blueprint, global blueprint, and which shows that where all globally we should be working together to address the challenges is happening for climate change. And when you see it encompasses 17 goals, which is interconnected. As Dr. Chidambaram has said, I enjoyed his talks, was very addressing to about SDGs and also climate change with water and sanitation. He said so many things, he elaborated very well. But when you see in Indian context, according to NITI 2024, SDG India Index 2021-2022 was above like 60% with like percentages, where Kerala and Tamil Nadu was in the first. So when you see, but we are not achiever, but we are front runner. So globally, now, according to the UN target for these SDGs toward 2030 agenda, now we are like 15% for achieving in all globally when to achieve this target. But we still having big gap. We still having big gap and what to do in the various certificate government and also individuals that to make this happen. But now only like we have a half of a decade to achieve these goals. So we need to work hard that in a various subject that we can do something better. Because when you see, we still have things to do that. And when we say sustainable development goals, we have key stakeholders. The key stakeholders we have is government and the corporate companies like industries, higher education institutions, and even individuals. And both are doing so much difference that once we work together, we can achieve this. Because sustainable development goals, it's not only for government, it's not only for even corporate, because especially higher education institutions and the industries are playing killer important to achieve these goals. So for individuals, we are asking to be like personal choice, consumer behavior, and grassroots movement. So we should start thinking about how do we to live sustainable life in a different way. So because this will help us to reduce the emission and waste through all our consumption and production. So there are key role of higher education institutions and the industries to address these challenges, because higher education institutions are offering like research impact, but while when we integrate with industries, we can make something better, because higher education institutions are crucial for educating people because it's considered as microcosms of society for future society. So when we educate people toward sustainability in everything, because I believe the awareness is a matter. So because the knowledge we have, because we have what we call awareness, and also we have the knowledge that we should produce for getting more what we need, but also we should live sustainable. Because you should have the mindset what once I'm going to purchase these items, I should think about the planet, environment, and also society, the people around me, and also should be about profit or economy. So not only just I saw something, I purchased, I bought it. No, you should think about everything when you're going to decide. So what you're gonna do, purchase either economically or also your personal needs. So higher education institutions are very key important. So to address these challenges, through sustainable campuses and initiatives are implemented in students and teachers, and also various partnerships. So I would like to address something related to higher education institutions toward the sustainable development goals. Among of them, it's about quality of education. The data and the metrics are showing that worldwide, and reading proficient among children has improved by 14% since 2015. So, but Indian metrics is showing that India school enrollment rate has risen to above 76.34%, and also about 20% of increase in standardized test scores. So globally, when they're saying for this quality of education, so they will want to have the education for all. But now they still having a challenge, specifically for developing countries in rural areas. The children are still not going to school, and also about sustainability, to integrate sustainability in education systems require specialized teachers, because how the curriculum should be integrated and with sustainable development goals, and how the institution will be implemented in either in a workshop, either in a different coursework to train the student, to think sustainable way. So I would like to say something about this clean water and sanitation. But when we say about this, because I'm based on the global agenda, So we have seen that global has been good achievement for 71% of global population now are having access to safe water, drinking water. But even if we have achieved, we have seen some countries in Africa which we still have lacking the safe water, drinking safe water. Like even more than 3 billion globally are still not access to water, safe water. So this is a challenge we have, but India, we are scoring good because we have been improved and access 40% since 2015, and also sanitation coverage 95 nationwide. So when you see here, in the report was reported here in the UN 20 this last month, 2 months. So India government Jal Jeevan missions aim to provide piped water to every rural household by 2024. So by launching in 2019. So this program is showing that India has been trying to provide the water sanitation to rural areas. Above 60%, they have been achieved the target, but we still have more to finish the target has implemented by Jeevan mission. And also another one, 2 sanitations, Indian Swan Bharat missions has significantly improved sanitation infrastructure. So to construct over 900 million toilets in rural areas. So in globally for improvement, when we see when they are doing evaluation, they have found that there is something improvement for sanitation and health improving. Like life expectation has been increased, and also disease has been reduced. But we still have problem because there is some countries still have problem related to water sanitation and sanitation. So, and some companies in India, like PepsiCo, for example, has reduced the water use in its manufacturing and over 60% through water recycling and conservation effort. So, Dr. Chidambaram has said something which is very important, I saw, related to water audit like a water cycle economy or reuse and recycling. This is very important. We are in a generation that we should not use water, especially in the higher education institution or any companies. We should not use water only that one then finish. We should integrate in our colleges STP or STP sewage treatment water plant. We should have even a gray water treatment plant that we can use after that water, because even more than 40% natural fresh water are used in agriculture and gardening. So once we take water we have used in our institution, like in the kitchen side, and treat that water, we can use for gardening, for irrigation, so that we will be able to save water. So, but the problem, we are using linear only. Just we take it from the tap, then we are wasting like that. That is the mindset we should shift if we want to do for sustainability life. Another one I want to take, because the biggest contribution to this recovery of ozone layer, it's about affordable clean energy and the cycle economy. This is 2 emissions in the report has said that, because through the collaboration, the partnership for globally in different countries to start, implement, and invest more in renewable energy and the cycle economy, that is reducing the emission, because transportations and industries and energy are the much more which is emitting carbon emission in atmosphere. So once we are involving clean energy, renewable energy in our everything, in our every life, we should reduce something which is very big, because globally we have now 2022 we have achieved 30% for power generation related to renewable energy, mostly like solar and wind installation. So we should have to think about it. when you are going to conduct like a sustainability audit, there is something which is important. We need to focus on that. Because people that are claiming that our institution are sustainable living, but when you're going to calculate a sustainable audit, you're going to conduct that. There is something which is important we have to see. One important is renewable energy you are integrated in your college. At least when you have more than 30%, when you have 30% of renewable energy using in your institution, we can say that this institution are sustainable living. Because the emission and the purchased energy are more cost in everything in our sector. We should think about everything. Yeah, so there are some things I can say because of time. I'm not going deep to explain like that. Another one is another goal, number 9, for industrial innovation and infrastructure. There is somehow the manufacturing has been increased through global industry and research development and internet user. But the most important nowadays we should focus is this about AI, artificial intelligence. Artificial intelligence nowadays is working high to help us in different things. AI and sustainability in production, in our work and career. We should not, we should upskill our knowledge about using in AI, but for sustainable living. So we should think about in our subject, in our life, because it's doing something, but we should use in the better way, which is social and the environment should be balanced. Because when from the statistics from 2021, the global economy from different top companies like Microsoft, like Amazon, like has been increased due to this using AI, and also many industries now. So we should continue to think that problem what we see in water scarcity, the challenge in addressing climate, we should think about, because while using AI, we are producing more, but also we should balance it for ecological system. There are some case studies like Univel Nederland. For this case study, they have reduced the carbon emission from energy used by 64 from 2008. So they have achieved zero waste to landfill across 100%. So, and this is the benchmark. So when in sustainable living, we have 3 important things. One is the sustainable goals. Institutions should sit and say, in 5 years, we need to increase renewable energy at least 30% or 50%. And we need to reduce waste and using zero or having zero waste in our institution, at least in 3 years, like 60% or 50%. And the waste and water management will do like this. So once we have that, is where we see that the target and the metrics to see if we have data, and also we can make the sustainable analyst to see our institution is located in this stage. So this industry, which is producing many harmful products, they have achieved 100% of zero waste. We should continue to think about, and it is happening through plastics, through different things we are using. We should continue to think about individual, because this is not a need activists or expert, but we should start to think about in our side. Then another case study, University of California in the USA has been ranked #1 in university green power. They have 244% of renewable energy. Their energy are based on renewable energy. So this is something which is better. They have most of the time I used to visit their website. They have what we call climate lab. So they, from the food for drinking, everything in their campus. So they live like it's a clean and a green campus in globally, because where they integrate the renewable energy option, and also by using this red green building certification. So this is where I'm gonna try to finish here. Then after that, I will be speaking something, then I finish. Responsible, this is the topic, responsible and consumption and production towards the circular economy. This is where everyone, me and you, we are addressed. Because we are responsible for how we live, what we choose to do, what kind of car you need to purchase, what kind of house you need to live in, what kind of food you're going to consume. Responsible consumption from when you are cooking the waste from your kitchen and where you're going to dispose. It starts from here. So now that should be going to be composted or for recycling, we should be more responsible. So there is some companies and metrics showing how people that are increasing. But the problem when you see in India, we produce above 62 million tons of solid waste management, but the 30% are able to be recycled. So do you understand when we see the problem, the studies comes from plastic, microplastic, the pollution comes to drainage system and the rivers and the where, because we are not able to recycle 30% of 60 million of tons of waste only will be able to recycle. This challenge, we should think, students and also researchers and everyone, we should continue to think about how we can reduce this challenge, because this is responsible for climate action. We're responsible for climate action. Each goal is connected to another. They said that the reason why a Millennium Goal, development goal has been failed, it's because it was not connected. But each goal here in the SDGs is connected to another. Once we're responsible for consumption and production, we're addressing for climate action. We're addressing to each and everyone. So we have to think well that we can do better. And the climate action, so this is a report on 2018. So the world top emitters of carbon dioxide, first one is China, and the second is the USA, but it has been reduced. Now India will become in the second. So, but we should continue to see how always we should try to reduce this emission through everything. And this, again, it comes for all key stakeholders. Don't say there is one who is responsible for that. Globally, impact, natural disaster related death decreased, but we see that it decreased by 30%, and globally, and 85 countries have been adopted the national climate policies. This is a very big achievement, and India commitment aiming to reduce emission intensity by 45 towards 2030. So this is very also important. Higher education contribution like IIT Delhi, climate resilient infrastructure design have been adopted for 50 cities. And also some companies also reducing emissions. So this is very target we have. We should try to see everything we should do. And when about to finish, some strategies. In India, we have some ranking like NL4, like NEP, like NAC for accreditations. But UNESCO has been planned something like a framework towards SDGs specifically for higher education institutions, colleges and universities. They have given like a framework how we can integrate your sustainable development goals in your college, from starting conceptual alignment, rational to stage long-term sustainability. This is when I go through that material, it shows every guidance how you can integrate in your college. And the best things are they are providing certification process. This certification, which will be institutionally being certified for 3 years, and they are doing for free. But what they ask, if you want to be certified by UNESCO, your college or institution, you have to do all these process. These are the process where you have to do your assessment yourself. As an institution, you go to UNESCO, then after that you go through that. This new strategy has been published by last 3 months in July. They have been adopted this, and institution, higher education institution, can extend, who are extending SDGs, is it going to that? Then they give digital badge. They give digital badge per each SDG you have been contributed, and after that, your badge will be mentioned there to their website, and also for 3 years. This is a good reputation for institution. But you should know, if you're going for your assessing, because the assessment you will do by yourself, but they be expert to verify what you are doing. So online, they will be verifying everything. But once you excel in your any SDGs, at least is it 3 SDGs. Especially maybe quality of education, maybe climate action, maybe affordable clean energy. Mostly there is some SDG which is connected to education institution. So once you have score high, they give you certificate, and this certificate will be very important for your institutions. So, and according to Economic World Forum, this is what they are saying. Toward the SDGs, there is some top 26 skills for 2027. You see, the first one is critical thinking. This is the kind of jobs opportunity are available right now, because we should think and excel because in everything we do, to know that the world has been transformed, the way we think and we act. So the most important toward sustainable development goals, it's not require more expert. It's about for us the changing behavior, how we live and how we act in our everyday life. So then, first one, think. Whatever before you're going to decide using your money, doing anything, but think about you, because sustainable development goal, it's about meeting our current needs without destroying future needs. It's about planet, about environment, it's about economy and others. Think, listen, and also act. Once we do this, we can achieve sustainable living. So, then I can say that this is very, some differences. I get it. So there is, this Robert has said that the greatest threat to our planet is to believe that someone else will save it. This is the great challenge, to believe there is someone going to change without us. So together, we can make a difference for a sustainable future. And if not now, then when? Who will do that? Thank you for a kind attention, and very glad to be here. Thank you so much. If any question, you can ask. Thank you. Is there any question?
Thank you, sir, for your admirable talk. Now, I request Dr. M. Rajamanikam, sir, to honor Dr. M. Mahalakshmi, ma'am, with shawl, memento, and certificate. I'm honored to welcome Dr. M. Mahalakshmi, ma'am, an Indo G20 faculty, Assistant Professor, Grade 3, Vice President of Civil Engineering and Association at School of Civil Engineering, Shastra University, Tanjavur. She holds a PhD in Environmental Engineering. She specialized in design, operation of water and wastewater treatment plants, the principles of water supply and sanitary engineering. Her expertise expands to remote sensing and GIS applications, which she employs to enhance environmental monitoring and assessment. I kindly request Dr. M. Mahalakshmi ma'am to deliver a keynote address. Welcome, ma'am.
Good afternoon, all. It's my great pleasure. First of all, I would like to thank Dr. Selvam sir for providing this opportunity. I want to give some general topic related to air. Because compared to water, air is also an important component for our life. So how nowadays air gets polluted and what we are going to do in future generation. That is my topic today I have chosen for this case. Then basically I'm an environmental engineer. Then I have working in water and wastewater treatment technologies. Then even though just I want to give some general aspects of air. So this is I'm taking here tackling air pollution, policies, practices, and for the future generation. Here, this tackling air pollution, it requires mainly, it is a comprehensive approach because we need to combine the practices, best practices, innovation technologies, and a commitment of the sustainable development. So here, so we know everyone it's know that is what is air pollution because air pollution it is a basic presence of harmful substances which is available in the atmosphere affecting air quality as well as in the human health ecosystem and the climate everything it can be affected because of the pollution. And in this case this pollution which we know these are all the major things mobile sources, stationary sources, area sources, all these three comes under the category of a man-made activities. Not only man-made activities, even though we have some natural problems which creates the air pollution. So in this man-made activities, the mobile sources in the sense that is the transportation. Because of transportation of a particulate matters as well as a gaseous pollutant, which transfer from one place to another place that is comes into the category this mobile sources. It is mainly from the transportation activities. And this stationary sources in the same place where it's generated, that is like in the community places like industry or community household activities as well as agricultural activities, residential places, everything which creates the air pollution that comes under this category of a stationary pollution. And in this area sources where we are doing some agricultural activities and construction demolition works, everything produces a air pollutant. And not only the outside environment, even though in our inside houses we are facing this air pollution, because compared to people they are most of the time they are living inside of the houses, that it includes the indoor air pollution which includes we have cooking, then because cooking which we can go for a heating and other processes. While doing this the pollutant which generate more, it mainly releases a carbon monoxide, methane gases, everything, VOCs, volatile organic compounds. These are the major components we are facing. And before that, I want to convey this is a air pollutant. It's major 6 pollutants or the important role acting over here. This is carbon monoxide, methane, sulfur oxides, nitrogen oxides, VOCs, everything. These are the major criteria pollutant we can face of it. And poor ventilation inside the houses that also create a pollution. Then freshly painted rooms, scented items, whatever, even we are using hairsprays, scent, perfumes, everything which creates a lot of pollutant inside the houses. And even smoking which produces more than 4,000 chemicals, different chemicals, which includes carbon monoxide, formaldehydes, everything which released to the environment. And now this is a current status of our air pollution. So here I want to register here. We are facing a critical issue on this case in India, because India currently significantly air challenges mainly on this criteria, like around top 10 cities of polluted cities, 9 cities from India. So here, Begusarai, which produces 118.9 microgram per cubic meter. This is a particulate matter 2.5 ratio, but the limit of WHO standard is only 5 microgram per cubic meter. But now in Indian city, it releases 118.9. At the same time, while considering for a Delhi, in particular Delhi, which holds the highest record of particulate matter releases every time, every year it leads a part of it, and especially during Diwali celebration, it reaches a maximum rate. And compared even this Diwali in October 31st midnight, we can reach around 608 microgram per cubic meter of particulate matter released in the Delhi. So which is more than 13 percentage compared to earlier years, 2022-23. It is 13 percentage higher than the last years. So it released on this. And accordingly, we also need to analyze the air quality index. Air quality index means it is one of a value that it can be measured from the concentration of the pollutant. That value, we can measure that air quality value. Based on that, we have to give some standards of the particular locality. And these are the air pollutant emissions in compared to present status in 2040. This is the variations what we are going to face: the release of sulfur oxides, nitrogen oxides, and particulate matter 2.5. So compared to particulate matter chain, the particulate matter 2.5 is a huge harmful substances. And these are called air pollution episodes. These are some of the case studies what I have collected. These case studies means, the episode means some of the periods what we have faced a lot of concentrations based on pollutant concentrations, how the people are faced so many attacks. Like the first, this is it's even in the year starts from 1930, we are facing till today. So there are a lot of episodes on the events. The first one, it is which occurred in the year of 1930 in the place of Belgium, Meuse Valley. Here, it is a region where it provided some industries. The industries where it is located in the place Belgium, it is zinc smelter, glass and steel manufacturer industries. Those industries, they released lot of pollutant in this particular locality, and it affected the people, those they are living. It mainly focuses the respiratory system. So respiratory system is totally affected, and it was recorded around 63 people death because of the release of this gases, and also cattle death were reported, and approximately 6,000 people were relocated. And this is another episode occurred in 1940. It is Los Angeles. What we have weared some masks during our COVID time, right? Those similar type of masks the people were wear in the year of 1940s. Even that locality, there was a World War II. In that time, there was a severe air pollution problem experiences in this Los Angeles. And this is another report from 1948. Here it is a place of Donara. It is a town which is located near the river, and it is poor topography because of the pollution dispersion. So here it is, the topography is very poor. Lot of pollutant can be disposed in this locality due to those industries, zinc smelters and blast furnaces. And this is another episode in the year of 1969. There was acid rain in the place of America, then East Chicago. It releases sulfur dioxide. We know sulfur dioxide and nitrogen oxides are responsible for the acid rain, right? So which produces acid rain, and it releases to precipitation of sulfuric acid and nitric acid. And because of this acid rain, There was a changes on even trees and the birds. Birds are also lost their feathers. Not only human, everything, plant, animals, birds, everywhere it was affected. This is another episode in the year of 1978, West Virginia. This is also another acid rain. This is 5,000 times more acidic than the normal rainfall. It was happened in the West Virginia because the pH of the rainfall was measured 2. This is another one in Mexico in the year of 1950. So here there was a petroleum producing region. This disaster happened in 1915, and because of this, there may be release of hydrogen sulfide. So this hydrogen sulfide, which released and from the oil field accidentally, and it produces 22 sudden death and 320 hospitalized. And this is another episode in the year of 1976, Italy. This is also an explosion of chemical industry. And because of this, dioxin can released. Due to this, there was a human carcinogen, and also 19 children were admitted to the hospital because of the skin issues, abnormal skin growth. And this is a well-known one, our 1984 Bhopal gas tragedy, because it is released by the chemical leak. It was happened during midnight, and this is one of the worst in industrial air pollutant history. And the industry which released methyl isocyanate, which escaped during the progress. And because of this, lot of people were suffered, and almost the death recorded 15,000 to 20,000 at that time. Even still, the people are suffering in that particular place. Then this is recently 2001. This is World Trade Center. There is a terrorist attack. It was happened because of this. Exposed 1,000 people may be died, and also create lot of environmental contamination. Then it releases toxic smoke and fumes released, and still the people are suffering. And another one is on Jaipur in the year of 2009. It is a vapor cloud explosion. This is also from another industry, Indian Oil Corporation, which depart in Jaipur. Then 11 casualties because of the sudden incident, and 150 injured. 5,000 people are relocated. And another one is in 2020, Vizag gas leak. This is also in India. So because of this, a lot of people affected by respiratory issues and irritation. 12 sudden death and cattle death were hospitalized. People of around 585. So those are the episodes, whatever we seen. These are some case studies. So apart from lot of case studies, there are lot of attacks, lot of problems we are facing still today because of this air pollution. So what are all the impact we are facing due to this air pollution? The major one is health issues. So the health issues mainly in the outdoor as well as indoor. So both places we are facing, and even estimated in the year of 2016, 4.2 million premature death worldwide it was recorded. And in the 2020, based on indoor pollutant, it was recorded around 3.2 million death due to only health issues. And climate is one of the major part in this air pollution, because globally it will increase temperature as well as all the climate variations can be occurred. And water, due to monsoon replacements, there will be the problem. And the energy, we can have lot of haze and dust which releases from the air pollution, that also reduces a lot of energy, as well as food crop productions, cultivations, everything can be modified because of this pollution. And major thing is respiratory health effects that we are facing. These are the problems we can face, like bronchitis, asthma, then COPD, everything can be. And also it reduces the lung function, even cancer issues, everything can be created. But we can have some mitigation strategies. So we can go for some clean fuel and stoves, and ventilated homes, proper ventilation we need to provide it, and air cleaners. And wherever is required, we can go for a face mask. And active transport. Active transport means instead of going private vehicle, just we can avoid wherever possible, we can go for a public transportation, or we can go for short duration, we can use a bicycles, even good for health. And we can go with the low air pollution routes, we can choose for it. And vehicle, proper maintenance of a vehicle, Just we can avoid the release of more carbon monoxide in the air, and plan exercise properly, and local air forecast, everything. That these are some medication strategies we can go for it. And we also measure the air pollution by the terms of scales. We can go for micro scale, meso scale, and macro scale. Micro scale means within the short duration, the pollutant is produced in this place. Only the pollutant is circulated around this within 100 meters distances. That is, we can call it as a micro scale pollutant or pollution. And if it may be meso scale, it local, urban, or regional. Local means within a 5-kilometer range, the pollution can spread over. If it may be 5 to 50, it is called as a urban pollution, urban scale. And if it may be up to 500, we can call it as a regional scale. And if you go for a macro level, it is continental and global. Continental in the sense 5,000 to 1,000 kilometers, and global in the sense it is a extent of worldwide, whatever may be. So here, this is the micro scale. We can say it is an indoor air pollution and dust particles, because within 100-meter distances. And meso scale, we can take photochemical smog, acid rain, visibility variations, and exposure to traffic. Maybe it is urban, regional, or local levels. And the macro scale, we can call it as global depletion, ozone layer depletion, global warming, greenhouse gases emission. So everything, because globally it was affected. So these are the different scales of air pollution that we need to know. And these are some of the environmental protection program. Not only this, still we have more number of protection activities we have started and initiated. How can we reduce? How can we go for? How will we go to create some innovations to avoid the air pollution? Then everything. The people have started in the year of 1972, the first World Conference to Protect Environment. This committee, they can start it, that is joining with all the countries, and they can give that is common rules and regulations, everything they had started to implement. It was extended in the year of 85, 87, 88, 92, 95. Still we go for it according to the way. Just we are providing so many innovations, a lot of rules and regulations. Just we are implementing and revising day by day. And this is called the air quality index. As I said earlier, there is some numbers just we can calculate the air quality index. It is like a measurement. So the concentration of the pollutant measurement, that can be converted as a number, that is AQI value. So basically the AQI value, whatever, if you are just you can find out what is the AQI value for Thoothukudi today. Just you can check it over. So tell me anyone, what is the AQI value for today? Find out. Just you can search, it may gives AQI value. Okay, tell me as Chennai. Yeah, 35. So it is in the good range. Okay, if you go for identifying the values, maybe for Delhi, that will be more. So even I said earlier, the Diwali time, the Delhi, it reaches around 350 something, 380, 390, it reached up to. So now it is the value, if it may be 0 to 50, the range is good. That it shows in green color. What it seems, that place is good for every people. There is no problems to the people, those they are living in that locality. And if it maybe reaches from 50 to 100, it is moderate. It may be good for all the people, but it's not good for sensitive people. Sensitive means already they have some issues, respiratory or some other diseases they have faced, they can have something, some issues they can feel. Then if it may be more than 100, that is unhealthy for sensitive groups. Again, so it may be unhealthy for normal people also, because if the people is long duration, long exposure on the same place, it also unhealthy for normal people. But even a sensitive people, it is unhealthy. Exactly. Then 150 to 200, it seems in red color, unhealthy for all. It may be longer duration. Similarly, very unhealthy. If ranges go from beyond 300, it is hazardous. It's not a place where we are going to live. So we need to purify the place. That is our aim. So we have to recall the air quality index, and we need to give it in the good zone or moderate, at least moderate. And what we have to do? So we know these are the problems, these are the issues. What we have to do? We have some control technologies. So control technologies, it's not only the technologies, we people also have to do something. So there are three things. One, first thing, that is we can control at the source. It's possible, just we have to control at the source of emission, where the air pollution starts. That we can avoid to replace some raw materials. If raw materials we are using the same materials again and again we are using, that will create a lot of issues. So we can replace some new materials, or we can go for alternate materials. As well as we can go for the modification of the equipments, whatever we are using. This is at the reduction at the source level. Then we are not able to reduce at the source. What we have to do? We can go for the next stage. How can we control it? There are two things I said earlier. One is a particulate matter, another one is a gaseous pollution. So particulate matter, we can go for a lot of technologies nowadays we have. Because all the industries, they need to provide, they have to install the devices. That is like a gravitational settling chamber, cyclone separator, fabric filter, soft X-ray, ESP, electrostatic precipitators, wet collectors. These are the devices, application devices we have provided in the industries. They can control this particulate matter. After that, they can release the gas. So these wet collectors, we can have different methods. Wet collectors means that is like a adsorption. So adsorption, the particles can attach on the surfaces. So we can have sprators, cyclonic scrubbers, Venturi scrubbers. And then go for a gaseous control devices, we can have wet absorption or dry absorption. So these are different technologies we can use to control the pollution in the industries or house. And after that, we also go for the rules and regulations. Just the industry should know this much quantity only should release it. The concentration of the pollutant should be restricted. That industry should follow these rules and regulations. These are the ways to control the pollution. And this is a air quality monitoring. How can we monitor the quality? So first we have a air quality monitoring stations, different stations they have to provide, and they need to analyze. What I said earlier, this is a pollutant like SO2, NO2, particulate matter 2.5, 10, everything. So that should be analyzed properly. Then that data can be taken. That data, it is taken for the analysis part. So then we can identify what is the air quality index value. So that's what we can go for the air quality application services, and we can find out we can get the cloud data. It is like IoT sensors. We can use it. Then this is innovations in quality monitoring, then data processing techniques, and we have to collect the data and data sharding, then analysis, then this finally we can predict it. And we need to proper monitoring stations. That monitoring stations provide the quality value. If the quality value may be increased, just they have to go for the steps taken to avoid it. In quality management cycle, so we need to determine the emission reductions. First we need to determine how can we reduce the emissions, then we need to go for the control strategies and implement the proper programs, and we can go for undertaking ongoing evaluation. If we go for everything properly, we can get and establish the goals. Our goal is to give a better life without having any health issues due to air pollution. Then these are standards. Even in 1982, air quality standards, there are only 3 pollutants are considered major pollutants, because it is in the air only sulfur oxide, nitrogen oxide, particulate matter. But in this revised quality standards, it was included 7 pollutants as major occupation of 7 pollutants in the year of 1994. After that, it was revised again 12 pollutants after 2009. Now it is on increasing. Number of pollutants is going on increasing. Then this is our best practice to improve our air quality. Just we have to regulate our breath, air, what we are going for a breathing, and where we go for a breath, and frame air quality laws in a proper way in terms of a public health. We need to concentrate on the public health and also hold institutions accountable and ensure proper in the public participation, and also keep up with the latest sciences. Whatever advantages, technologies, whatever we had, everything we can incorporate, and we can get the best practices. And this is a waste management hierarchy. Here, we can take a most preferable should be the pollution prevention. That is, source itself, we have to avoid it. If not, we can go for reuse. Also not possible, we can go for recycling. Otherwise, we can go for treatment. So if nothing is not possible, then only we can go for the disposal. At the least preferable is disposal. And this is a GDP. So compared to, because GDP is one of the major thing in the world. So now the countries which lost the GDP value because of this pollution, India occupies the second place. We can last 5.4% of the GDP in every year. So we need to avoid this. And this is our aim. We have to recollect what are the pollution. Create some awareness, that's all. I'm not giving any technical terms or nothing over here. Just each and every place, just we have to go for some innovative techniques. Just we can avoid the pollutant, whatever possible in our side. That's all. So thank you for the patience. Any questions?
Thank you, madam. Very excellent presentation.
Thank you, ma'am, for your interesting talk about tackling air pollution. I would like to invite Dr. A. Ramachandran, sir, to honor Dr. G. Muttushankar, sir, with shawl, memento, and certificate. I gladly welcome Dr. G. Muttushankar, sir, Head of GIS Projects, French Institute of Pondicherry, Pondicherry, India. Welcome, sir. With nearly 20 years of research experience, he is a leading expert in the fields of remote sensing and GIS, particularly focused on environment monitoring and climate-related studies. He holds a doctorate in remote sensing from Bharatidasan University, Tiruchirappalli. He had been actively involved in various international projects and collaborations. He had over 100 research publications in esteemed journals. I kindly request Dr. G. Muttushankar, sir, to deliver keynote address.
Thank you for the introduction. First of all, I'm thanks to Dr. Selbam and other colleagues in Geology Department. I'm happy and say V.O.C. College. I did my BSc Geology 1988 to 91 in V.O.C. College. So I'm very much proud to standing here. Thanks. Our senior also is here. Thank you. Yeah, please. Yeah. So I'm working in French Institute of Pondicherry. It comes under the French government institution. Actually, you know very well, the Pondicherry comes under the French rule. So that time, 1954, they started the special treaty between India and France. They started the one small research unit in the Pondicherry area. So French Institute of Pondicherry. We have 4 departments, research department. First started at Indology. Yeah, this is our institute. This is one. First started at Indology, study about Indian studies, all things. Then we have ecology. Then social science. Finally, we have geomatics also. So 4 departments there. I'm the head of the GIS project in this Department of Geomatics. Okay. So today, yeah, just I taken for the here because our goal is air and water and sediments. So I taken this one, saltwater intrusion in the coastal aquifer. Not only saltwater coastal aquifer, although I am touching the what are the vulnerable in the coastal area. That also I am touching here. Okay. Because yesterday our VC told about the coastal problems, all the things. So I did all the touch on this. Okay. Just first, yeah, sorry. factors that affect the saltwater freshwater interface: sea level rise, then decrease in the recharge, then increase in the pumping extraction, the major reason. Okay. Global scale climate changes. First, we will check the global level, then we can local level. Global level, rising of the seawater level. This is a slow poison only, because I will touch all the things. Then change in precipitation. I think we are now experiencing all the things, because last year our Thuthukudi and Tirunelveli we received nearly, Kayalpatnam received 90 centimeter rainfall. Our year rainfall, that is within a day we received. My native place Mulagarapati received 74 centimeter rainfall. Average rainfall is 8 mm only, but one day we received. Because within the short duration we are getting more rainfall. That seasonal rainfall we are getting. 2 or 3 days we are getting the entire one. Then change in temperature. Now is up to November, December we need to put the AC because 2 or 3 days only the rainfall is there. But in this time in Pondicherry and Chennai region we are facing everywhere we are facing the hot period, because after the August, November little bit reduce the heat. But now because already the started climate change is all started. Okay. Then the causes of the local level, increasing consumption of water, because our population is increasing, so our water need is more. Then our food, for the food purpose, industrial purpose, we are extracting more and more water. Okay. Then the pumping, there's the pumping, and then agricultural industrial activity, increase in development. So everywhere we are making the new smart city, all the things we are entire road and concrete pavement, all are we are doing. There's a lot of developments are going in this one. That is also okay. Now, this is a problem for the recharging. Then another thing, the cyclone, because of the cyclone, stormwater, the tsunami is the rare one. So stormwater surge, inundation, water inundations are happening. Seawater inundation is happening. Then coastal erosion, both natural and anthropogenic. We can see this is just causes. Then finally pollution because of the pollution also. Okay. The overall pictures, coastal aquifer, because of the first in the relative sea level rise. Then another is one coastal zone, coastal erosion, shoreline retreat. Then human activities, I already told, groundwater extraction, land reclamation, and then that's it. Changes in hydrological regime. Just now the professor Dr. Steele has told, base flow water is now is reduced. Particularly our eastern flow rivers, all taking from Kaveri, Tamaravarni, all are now the base flow is reduced. All the rivers we are constructing the check dams for stop the inundating the seawater. If you take the Punnakayal area, they constructed the dam, check dam, because the seawater intruding in the land. Same our Kaveri and Kollidam area, we are did like that. All the check dam we are doing to construct the check dam for stop the inundation of the seawater inland. So that is the situation now. Because base flow water flow is very less in this one. Then affects seawater intrusion, increase in seepage, decrease in groundwater resource, salt damage crops, degradation ecosystems. Okay. So coming to our area, I taken for the Coromandel coast. Coromandel coast is Cholamandalam. It's from Ennur to Pulikat Lake to up to Vedaranyam nose, Pine Kalimar. We taken this one. So here we first generally with the natural one, we will take the natural reason, sea level rise, already told. Then cyclonic storms. Then the monsoonal wave forcing and oceanic currents. And finally, coastal erosion, natural, because this is all natural. Then another is because of the anthropogenic effects, growth, population growth. I already told population growth. Then ever-growing industrial and harbors. So all the development is happening in this region. Then coastal erosion, anthropogenic, because of the natural also there as well as the anthropogenic erosion. Then finally aquaculture and beach resorts are this type of the expansions also in the coastal areas happening. Okay. So coming to the sea level rise. Latest IPCC report saying 1901 to 1999, 1.4 mm. The recently 1970 to 2005, 3.2. Latest one, 93 to 3.66 mm. It's increasing. Coming to our Indian scenario also, if it there 2100, worst case 1.1 meter is possible. 1.1 meter is possible. Then if you imagine our Thoothukudi area or Chennai area or all low-lying area, inundation is possible. And this is one. This is only the model and projection only. This is where is this one. Then coming to the Indian is one. In our Ministry of Earth Science, they published the climate change report 2020. That's saying 3.3 mm per year is possible. This one. Okay, because of this one, increasing the shoreline erosion. Because if you ask to any fisherman, previously in my younger stage, that shoreline is there. Now it's coming here, because we are visiting lot of coastal, we have the program projects. So many coastal villages we are visiting. That time we asked to the fishermen, they are telling, because the erosion is now the erosion is more is happening. Then last of wetlands. A lot of wetland is because yesterday Professor, our Vice Chancellor told, even Thoothukudi also lost, Roche Park, last of the wetlands are lost. Not only Thoothukudi, everywhere. All the wetlands are we are losing. I will show you all this one. Using the remote sensing data, I'll show you all the things. Then finally, because of this one, salinization reason. Okay. Next, just the image is showing how if it sea level rise, seawater will introduce inundation. Saline water intrusion. The previous one was the current coastline. It's the current coastline. Okay, it's not working. Then if it's sea level rise, how the sea water will intrude in the land mass, saline water intrusion. Then another picture, just wetland degradation because of the sea level rise, how it will absorb. Close to the wetlands are, it will affect by the sea level rise. Okay. Then coming to the cyclonic storm. This is from the IMD cyclonic atlas I taken from. See, just I taken from the only the Coromandel coast. I told only the northern Tamil Nadu only I taken. Last 100 years, we received nearly 72 cyclone and depressions. Particularly last 20 years, 11 cyclone. Luckily, you are the safer place, Thoothukudi is safer place, but we are, I will show you this one. So the next one. For the small, we did the small analysis in the 1981, and the data is available from 1891. Is the IMD website? It's available. This data you can extract from that. 1891 to 2017, we taken this for this study. Nearly 98 cyclones as well. Deep depression is 41, cyclone 24, severe cyclone is 33. If you coming, your region is very less only. Thoothukudi region is very less only. So you can imagine the Puducherry and Kadalur, there is many. We are receiving every year the cyclone is there. So we did the analysis based on the depression and cyclone, and given the severe cyclone, we given the weightage, and we did the cyclone vulnerability index map. So the red color is highly vulnerable based on the fast cyclone effect only. Based on the fast cyclone, the red color area is highly vulnerable zones. Okay. Then just a few examples for this one. With the Thane cyclone in 2011, we received highly impacted in the Pondicherry and Kadalur area. Varda cyclone in Chennai region. Okay, nearly storm surges are 1.47, 1.4 meter. IMD is there is a PMSS, probable maximum storm surges. Every district within that. Particularly in Pondicherry 3.5, Kadalur 4 meter possible is an IMD is there. Even Rameswaram, Ramanathapuram is more, 7 it's possible, that region. Okay. This is the probable one. Then there is a Gaja cyclone, it's affect Vayataranyam area, that path is there. The cyclone is started from the east coast to up to west coast is extended. This Gaja cyclone affection on this region. Okay. Then first we saw the sea level rise, and then the cyclone impact because of the climate change, cyclone is done. Then the monsoonal wave and forces. We have taken from the daily data from the IRA interim data. It's a free data. It's available, freely available data. We taken that data and we work for this area for the current and wave energy. See, this is the current and wave energy. If you, the white color is the maximum wave energy in this region. So we taken the wave energy and current for this region. Okay, based on the monsoon wise we worked here. Okay, this is the current direction. So this is the basic for the erosion pattern. Based on that only, I will show you the next is one. Coastal erosion process. Coastal erosion process, I already told, natural and anthropogenic also. There is a natural is there. Because of the wind tide, there is natural erosion. You are a geologist, you know there is one coastal erosion. Then anthropogenic, already professor told, because of the sediments depletion, because we are constructed a lot of dams in the upstream area, so the sediments are, sediment flows are reduced. That is also one reason. Then constructing the lot of breakwaters, all the things. That also the problem. I will tell you all the things. I will show you. Coastal aggregation and erosion problem in this region. Okay. Then coastal erosion process. Just breaking the waves of removes sediments. Then the currents. Because of the wave force, just cut the sediments are removed. Because of the current, all are moving this one. That's why the erosion is happened. Anthropogenic effect. I told the anthropogenic effects, because where all the harbors are not natural harbor. If it Kochi is the natural harbor, if it Thoothukudi or Pondicherry harbor, Kadalur, Chennai, all are artificial harbor. That's why we are constructed the breakwaters. If we see, 1 second. Yeah. So before the Pondicherry beach, we have the good beach. That after constructing the this one harbor, because for the harbor purpose they constructed the breakwater. So now the total beaches are vanished, all are gone. So there is no beach, fully stone only. Okay, this is the same problem in Chennai also. South Madras, we have the good Marina beach. The same time, North Madras, fully, entirely, it's eroded. Ennur area, all are eroded only. Only seawalls only is there, boulders only. So now in Pondicherry, that beach is called Rocky Beach. There, people are saying Rocky Beach. Because of the anthropogenic effects only, we lost this one. Already sea level rise, all are happening. Moreover, our development also is happening this one. So after the construction, see the breakwater construction here, breakwater construction, here the deposition happened, here fully the erosion has happened in this region. Okay. Yeah. See we did the one paper in this, based on this one. See all the red colors, erosion has happened. So in Pondicherry area, what they did, all are seawall, they constructed seawall. Then again the Tamil Nadu area, they constructed the groins. So that also is giving the problem. After the construction groins, it's moving, that erosion is northward side only. It's not a solution, just changing the place only. Now the problem is happening in the north of that area. Now that area people are agitating. Again there is constructed in the university, Pondicherry University region. Again they constructing the groins. The problem is now shifted north. Not on this problem is not only in Pondicherry and this one. This is the world level syndrome. Wherever the artificial harbor is there, which fortress in the problem is there in this problem. Okay, these are anthropogenic effects of the erosions. So overall Indian scenario for the erosion and aggregations. Okay, then possible future climate change. Because we are telling future climate. Already I told decrease in number of rainy days and increase in intensity of rainfall given rainy day in the future. Already I told you this one. Then extreme rainfall and temperature are showing increase. No significant in the frequency of the cyclone storms, but intensity more. Because all now cyclones are coming in the very severe cyclone only. Past 3-4 cyclones we received, very severe cyclones only. So the intensity is more showing. This happened. Then population, you know very well, everybody is increasing only in this one. So another then industrial growth. Many industrial growth in aquaculture. Then beach resorts. Everywhere now is considered beach resorts also. I mean, then we taken the very high resolution image using the Google Earth only. We did the analysis for the some few packets. Then yeah, just a visual analysis interpretation only we did in this region. First we taken the from Pulikkad to up to Mahabalipuram area. Here mostly development, industrial and urbanization. Fully settlements increased in this area. Same time we received a lot of the cyclones and past 20 years, cyclones and depressions we received in this region. Quickly is one. Just I snapshot I'm showing. Just Ennur area, Ennur, Kattupalli, north of the Chennai area. Just 2004 only, not begin, just only the 20 years before. This is the Ennur area. Coastal wetlands are there in the coastal vegetation. 2014, fully the coastal wetlands are totally converted to industrial, and this one. 2017, all are gone. Full and full developments in this one. So this is like that. Okay. So you can see the 2006, 12 and 17, how the build-up area is increasing in this one coastal zone area. So developments. So improper land use, land cover changes is happening in this one. Okay. So then next, yeah, is overall, I just skip this one. Okay. This is a scenario, North Madras. Fully, there is no beach, full and full erosion, all are sea walls and rocky beach only, brines only. Then seawater intrusion of that status, entire Tamil Nadu is saying, there is an Anna University professor paper is saying this one. Okay, so full in. Then the next category area from Mahabalipuram to up to Pondicherry. Here more and more beach resorts. Population are increasing, the settlements are increasing. More development is many beach resorts coming here. Just to see next to our Pondicherry. That time is a good sand dunes, all coastal vegetation. You know the very well coastal area, a lot of sand dunes, coastal wetlands, all of that. Totally now it's all are converting beach resorts fully from Mahabalipuram up to Mahabalipuram. There is lot of changes here. So if you see previous one, you can get the idea. So 2002, 2014, 2017. So all resorts, all are converting the new settlements and the new plots are coming. This one, real estates are all are coming this close to this one. See the Pondicherry is one. So Pondicherry, government is published seawater intrusion. How much? It's nearly up to 2 kilometers in the city, 1 kilometer in the northern sides, seawater intrusion. You know, because here is a population, more population, extract this one. Apart from, there is a lot of tourism activities. So they extract more water. So there's some coastal tourism purpose, like Kanyakumari, Tiruchendur, Velangani, normal population plus more the tourists, they're more extract the groundwater. So the saline water intrusion is coming in this one. Then the next zone, from Kadalur to up to this one, Pichavaram area. So most of full and full industrial area. There is a SIPCAT 1, SIPCAT 2, SIPCAT 3, what in Thuthukudi, SIPCAT all. Like that, there is a 3 SIPCAT 1, SIPCAT 2, SIPCAT 3. All are Madam told that Kadalur also highly polluted, air polluted zone in Tamil Nadu, Ennur, and then next one, Kadalur district, highly air polluted. All are petrochemical industry only this region. Okay, just there is a Kadalur area, just 2006 image showing this one. This, you can see the nice fishing village with a good beach, you know, because the landing their boat is possible that time. This is 2004. After there is the one Nagarjuna oil refinery came this region. So they constructed the private pier in this, in the bottom. You can see here. They constructed. Afterwards, once they constructed this one, this beach is gone. This fishing village beach. Before I will show you. See, they having the good beach. After the construction of this pier, private pier, then because they want to, you know, material is available from outside only. You know, crude oil is coming from, there is a refinery, but crude oil is coming from outside only. That purpose only they constructed the small jetty. That because of the construction of the jetty, that fishing villages lost their beach. So what they did, the government did afterwards, groins. They constructed the groins. Once it comes to the groins, the problem is now is shifted the northern village, Periyapattu village. Now that village is problem. So for our, because of the development anthropogenic, so okay, this is the problem. Next, so entire this region, land use, land cover changes, how the settlements are increasing in this one. Okay, okay. So like that. Okay, then the last final zone is aquacultural. This area is full and full. The Nagapattinam area, aquacultural. Okay, their conversion is mostly aquaculture one. So overall, aquacultural in their area has happened in this last 20 years. Okay, so overall changes in this region. Okay, so industrial and research cycle, then the industrial area, and then aquacultural, it's happening in this one. Okay, then the waving natural forces, erosion places, then cyclone all happening. So the, yeah, so all are for port area, all are so highly, how much vulnerable we are living, you can see. That's why it is one. So just, because we are timing is less, I'll just quick this is one, because already we are hungry. So just we taken for the saline water intrusion study, just south of this Nagapattinam region. Okay, just a drainage pattern of this one, geology, soil information, geomorphology, land use, land cover changes, then rainfall. Then we taken the different data we used. Okay, so here we used different as one, shoreline changes, inundation risk, and coastal vulnerability, land use, land cover changes, then vulnerability to GALDIT model we used here. Okay, based on that one, just I missed one. There is a shoreline changes study. Then the inundation risk analysis, we use the digital elevation models for the inundation purpose. Okay, so if it the 5 meter seawater intruded, how much it will affect based on that one. And using the elevation model, we did the study using that one. So if it the 5 meter increase, what are the affections it will do? Because the tsunami time, inundation is happened in up to 10 meters. Some places 10 meters is there. So we taken the 5 meter, and because storm surge already told 5 meters one. So using that one, 5 meter inundation will happen. What are the land use will affect? That is we studied. Okay, is the villages, which are the villages which will affect that one also. Then coastal vulnerability index we used. For that we use the geological variables and physical variables are we used. Okay, so based on that one we did the index of this area, vulnerable index in this one. Other the villages are falling in this one. Okay, this is the land use, land cover changes. So here you can see the most of the agriculture under land reduced, plantation is reduced. One side, salt affected area increase, aquaculture is increased, salt pan is increased. That's the problem for the saline water intrusion. Then we did the GALDIT model using the groundwater and aquifer hydraulic type. So then the depth of groundwater level, sea level rise. Okay, so then distance from the shore, from 1 kilometer we taken that for the study. Then what is the actual problem in the seawater intrusion, impact of the existing status in the water also we used. Then thickness of the aquifer we mapped. Based on that one, we worked GALDIT model. So based on that one, vulnerable area we find out in this region. Okay, then the aquaculture also we can add up in aquaculture also problem to the saline water intrusion. So we taking together all in this one. So highly vulnerable zonation in this region. Same time we taken the another project, we taken the samples also, groundwater sample in this region. We did the pre-monsoon, post-monsoon also we did this one, this region. So overall problem. So driver pressure, state, impact, response. Already told physical and anthropogenic driver, then response structure and reduce the erosion, groundwater check dams, then physical erosion, coastal flooding, saline water intrusion, biodiversity risk. Overall scenario of the framework of this one. Okay. Yeah, this is the status of the entire India is facing the problem in this one, saline water intrusion in this one. Yeah, just saltwater intrusion remedial measures. I don't know. I'll just skip this one. So we European Union project we have, is the one part of work only I told, because there are a lot of things just for this one. So European Union project, there is 5 countries involved on that project. Another project is with the Bharatdasan University, is the Ministry of Earth Science funded project also. NCC are also involved on that project. That is also another project. So output of this one, the papers in this one, nearly 5 papers are we published, 6 papers are published in this work. Just okay, thank you.